Ma'am, are we starting or like?
Yes, let us start. So request everyone to make the most of the use of this session. You can ask any doubts or any queries you have related to the topic, right? So am I audible and is my screen visible? Please confirm.
Yes.
Your
Yes,
screen
yes,
is
please.
visible, sir, and you are audible.
Okay, okay. So let us start. So basically we will the outline of the I will just give a brief outline of the topic. So basically we will discuss about the pumps, what are the pump curves, and what are the different terminologies related to the pump. We will see two case studies related to what can go wrong if your designing is not proper, right? And we will do one example. We will size a pump, right? So we'll discuss all those design related methods how to size a pump, right? So let us start. So basically pump, we will talk about the centrifugal pump, right? So centrifugal pump basically operates on the principle of Bernoulli, right? So how basically pump operates? So basically the pump, we provide power to the pump, right, in form of electrical energy. That electrical energy is transmitted through like via rotary motion from the motor to the pump shaft, right? So there is some amount of losses when we transfer the electrical energy to the motor because of dissipation, right? So that heat gets dissipated whenever we transfer electrical energy from motor to the pump. So that is one of the heat losses, or you can say energy losses happening in the motor. That's why we see motor efficiency is 85%, right? So all the electrical energy that we are passing to the motor is not getting conveyed till the pump shaft. So that is the losses because of the motors. Even you would have seen that in the pump motors, the motors get heated up. That is all because of the dissipation, because of the coils inside. That's why we have given the fins on the surface of the motor, right? Now when the rotary, that electrical energy is converted into rotary energy, rotational energy, and getting converted into pump shaft. So now between the shaft of the motor and shaft of the pump, there is some loss of energy because of coupling. So there can be something amount like 3 to 5% loss because of the coupling, right? If there is misalignment, if your setting is not proper, so that is one of the loss because of coupling. So now the energy which reaches the shaft, it basically boosts the fluid velocity, right? So why it is called a centrifugal pump? That rotational energy, right, through the impeller, it will rotate, it will boost the velocity of the pump. Now once the velocity of the pump increases, it is thrown outwards, right? As soon as it thrown outward, the basically head of the pump. Now as per the Bernoulli's law, what happens? Your pressure plus velocity head and static head, right? P, that is the pressure, v square upon 2g, that is the velocity head, and static head is gz. So it always remains constant, right? So basically what happens, static head is not part of this pump. So what happens, your velocity head gets converted into pressure head in the discharge of the fluid. And before that, so that is how basically your pump operates, right? So what we do, we provide electrical energy that gets converted into rotational energy, and because of that high rotation, high speed of the impeller, your fluid velocity increases, and that velocity head will be used to flow the fluid, right? So that is basically the head of the pump, correct? So now what are the different parts of the pump, right? So we will see. So as I said, the impeller, which is the only moving part, is attached to the shaft and driven by a motor. So impellers, there are different MOCs. There can be bronze, polycarbonate, cast iron, SS, right? So uh, like here it is mentioned that the impeller is made up of bronze. So why bronze? Bronze is a costly metal. Then why we are going for bronze? So one of the reason, we use bronze impeller in special cases, right? So mostly in class A solvents like benzene is there or heptane is there, right? We use basically bronze. So the reason of using a bronze impeller is when the bronze metal is there, right? If you strike this metal with any other type of metal, it does not generate spark, right? So bronze has an inherent property of not generating a spark. But similarly, if you have a CS, cast iron is there, and if you bang on, right? If you strike that cast iron with some another metal, there is high possibility of generation of spark, right? So sometimes what happen, because of some you can say some nut bolt is there which comes inside along with the fluid. So sometimes your pump might like your in the casing there might be some metal part, right? A small, even a small screw, if it comes inside, right, suppose through the strainer, if it comes inside the casing, then it might generate some spark. So for the safety, wherever we are using the highly volatile or low boiling solvents like heptane or benzene, right, we use generally bronze impellers, right? Now what happens here, when the water enters the eye of the impeller, right? So eye of the impeller is nothing but the suction. So high speed of the impeller causes some little amount of vacuum in the pump suction line, right? So that basically sucks the fluid, and as soon as that fluid is sucked, it is thrown outwards, right? So that is basically we are generating the centrifugal force, right? So as the water is thrown on the periphery, it is discharged from the other end, right? So it is similar like you have a, suppose you have a plate, right, and you have some marbles. So whenever that plate is fixed, so what will happen, the marbles will not make any motion, but as soon as you start rotating it, what will happen, all the marbles will move towards the periphery, towards the boundary, because of the centrifugal force. Similarly, we are using the centrifugal force, right, using electricity, and that centrifugal force is ultimately helping us to move that fluid, right? So basically we are increasing the velocity of the fluid, right? So as the water leaves the eye of the impeller, a low pressure area is created, causing more water to flow inside, right? So once the suction is proper, right, once the material is sucked in, it is continuously thrown out, so more and more amount of liquid will be sucked in because of the some little amount of vacuum, or you can say lower pressure zone created because of the high speed of the impeller, that is the eye of the impeller, right? So your pump will start operating smoothly, right? Once this velocity is developed, right, once this velocity is developed, as the water flows through the impeller spinning at the high speed, the water velocity is collected by the diffuser and converted by pressure specifically designed passageway. So what happens, your discharge, right, your velocity will be getting converted into pressure energy in the discharge line. So it is nothing but you will see that in the discharge line your pipeline size will be lesser. So basically what we do, we increase the pressure of the fluid in the discharge, correct? Yes. Clear how a pump operates? Yes. Any queries, anyone? Okay. So that is very simple operation of the pump. So basically this rotating part is called the impeller. The outer part is called the volute or the casing. At the center of the impeller is called the eye of the impeller. This is the discharge.
Automatically be recording.
Okay. I think someone is asking anything. Yes. Okay. So now when we talk about the impeller, right? So there are basically three types of impeller. One is the open impeller, one is the closed impeller, and one is a semi-open impeller, right? Can anyone tell me यहाँ पे जो impeller दिखा है या कौन सा type है? Open है, close है, semi open है? कोई बता सकता है? Yes, anyone?
Sir, it is the open impeller.
Correct. So it is a open impeller, right? So when to use which type of impeller, right? So basically whenever you are having some solid particles or some slurry is there, then you should go with the open impeller, right? With solid content, high amount of solid content, you can go with the open impeller, right? Whenever there is a clean fluid, right, there is no solid percentage. Whenever you have a clean fluid, clean organic mass or clean solvents, basically methanol, heptane, benzene, toluene, for the clean solvents with no solid particles at all, you can go with the closed impeller. And whenever you have some amount of solids less than 1%, right, so in that case you can also go with the semi open impeller, right? So we are going with the open impeller with the slurry service because if your material is choking or if it is slurry, then there is very high possibility that your impeller might get choked, and also high amount of solids will damage your impeller. That's why we go for an open impeller with the slurries, right? So now let us see what are the different pump curves, right? So this is the most interesting part. So if you are able to understand the pump curves clearly, then you are done with the pump, right? So again, I will request, if you have any queries, you can interrupt me and ask. Okay.
So can you please,
Yes.
hello?
Yes, sir.
So can you please describe types of casing?
Types of
Casing.
I'm not getting you. What are you saying?
A different type of casing that we are using in pump. Like you have said, open and closed type impeller, and the type of casing that volute type and some other type things might get.
So that is like we have three types of impeller, na? So one we
Yes,
have open type, semi-open type, and closed type. That I mentioned
yes,
already.
yes. And sir, casing that there is a same casing type.
Casing will be same, right? So it depends. Like casing में कैसा रहेगा? Casing will be like if you have axial entry or radial entry वैसा रहेगा, right? There like sometimes what happens in very heavy duty pumps, right? Mostly in cooling towers, right? So there you have two impellers rotating inside the pump, right? So it is called a between bearing pump. So in that case, what will happen? There will be one suction, right? It will be a radial suction, and that radial suction will split inside the pump. There will be two impellers at a time. Two impellers will be rotating in the single pump, and there will be single discharge. Again वो suction आएगा, it will get split into two impellers. Again in the discharge that will get combined. So sometimes like nowadays we have innovation, right? Sometimes whenever you require high amount of flow rate, right? So in that case rather than putting two different pumps, right, दो पंप लगाने की जगह पे आप एक ही पंप में दो impeller भी डाल सकते हो. That is called a between bearing pump. So basically casing के type it is related to the mechanical energy, engineering. So casing के type it will depend on what type of entry you are providing. It is axial inlet, radial outlet, or it is radial inlet, radial outlet, right? So it depends on that. Clear?
Okay, okay.
Okay. Any other questions? Anyone?
Sir, actually, I have one question.
Yes.
Actually, there is a relation of a viscosity somewhere with the type of impeller selected.
Yes, again it is related to the choking service only. So if you have mostly slurries will have solid content as well as higher viscosity. So with
Yeah.
viscous mass or material which are having higher melting point, you can go with the open impeller.
Hello.
Yes.
Okay, sir. So you are saying that
With viscous mass, like slurries which are viscous or there is some viscous material, you can go with the open impeller. But I would recommend for higher viscosity of the material, you should not go with the centrifugal pump. Rather than, if possible, you can go with the positive displacement pump. If your flow rate is less, then it's okay. Otherwise, you should not go with the very high viscosity is there. Then you should not go with the centrifugal pump. It might also choke the pump. Or you have to go with the jacketed pump. Is it clear, Rushikesh?
okay, sir. Okay. I think for a high viscosity, we used to have a gear pump or a screw pump. We
Gear
used
pump or
to
positive. Yes, exactly. Because what
positive
happens at
displacement.
higher viscosity, your impeller will draw more power. So in that case, it is not suitable, not recommendable. So mostly for dosing service or wherever there is high viscosity fluids, we will always go with the uh, reciprocating pumps or a positive displacement pumps.
Okay.
So someone is asking whether I am sharing, but yes, I am sharing the screen and I think everyone is able to see the screen. Correct?
There is a one doubt also.
Yes.
Can we use a positive displacement pump for a class A solvents?
Class A solvents you can definitely use, not an issue, but you should have a safety measures, right? So for high
Yeah.
pressure, you should be having a PSV. Your discharge of the PSV should be at a particular location, right, in a dump tank or somewhere, or again in the suction. So there is not at all an issue to use a positive displacement pump with a class A solvent. You can use.
Okay, I'm very specifically asking about the I'm asking about the piston pump or a plunger pump.
Yes, you can use, not an issue, but sometimes what happens, definitely from usage point of view that is not an issue, but sometimes what happens whenever you are using a plunger pump or a piston pump, the sealing should be proper. So when we say class A solvents, most of the class A solvents have very low viscosity, right?
Yeah,
So what
yeah.
happens if there is not a proper sealing, आपका piston के ऊपर जो rubber के rings होते हैं, if your sealing rings are not proper, so it might get escaped, right? So
Okay.
that is one of the possibility. और हम viscous fluids के लिए क्यों use करते हैं? Because they cannot escape those links. So sealing is proper. Similarly, when we
Okay.
talk about the gear pumps, right? So if we pump the water through that gear pump, you will not get the flow because the water escapes between the space between the gears. So
Yeah,
that
yeah.
gear pumps and PD pumps are mostly suitable for viscous fluids, whereas centrifugal pumps are highly suitable for the non-viscous as well as cleaner fluids like class A solvents or water. Okay.
Okay. Thank you, sir. But thank you for resolving my query. But I was thinking about an other perspective. मैं सोच रहा था कि अगर मतलब हाई प्रेशर पंप में जब यूज करते हैं, पिस्टन पंप हो गया, तो जो क्लास ए सॉल्वेंट रहते हैं उनका बॉइलिंग टेम्परेचर बहुत लो रहता है, तो somewhere वो kind of a compression or doesn't increase the temperature of the solvent by using the positive displacement pumps.
So
To be
that
specific,
can,
a plunger or piston pump.
yes, that can happen. Definitely that can happen. But usage point of view, there is not an issue. So if you are using a pump, see, similarly, that kind of issue can also happen in a centrifugal pump. Suppose you are pumping any solvent, and if you shut off the valve, discharge valve is
Yeah,
closed for longer time. So your
yeah,
fluid might get heated up in centrifugal pump also. But usage point of view, suppose you want high pressure, you want at very suppose there is a class A solvent, right, and you
yeah,
want addition to be done at very slow flow rate at suppose 10 liters per minute, then definitely centrifugal pump will not be able to give that much amount of flow rate, right?
yeah,
So आपको class A solvent add करना है 10 liters per minute के rate से, so how will you add it? There is no other possibility. So you can use a
yeah.
PD pump, not an issue, but you should give proper safeguards so that there is not an incident like fire, or in case of leakage there should be not it should not form any vapor cloud or any incident. From
Yeah.
safety point you have to think.
Okay, okay. Thank you, sir. Thank you. Thank you.
In that case what you can do, you can give, provide a you should lock open the discharge valve. So for any reason your discharge valve should never be closed for a PD pump if you are pumping that particular fluid. So आप discharge valve को lock open भी कर सकते हो.
Okay.
Okay.
Thank you. Thank you.
Yes. Any other questions?
No, please continue, sir.
Okay.
Sir, I just have one question, sir.
Yes.
Sir, like you said that the discharge valve shouldn't be closed while using positive displacement pump, no, sir. If there is any emergency, means what can we do in that time, sir? Like any plant emergency like that, sir.
Sorry, I didn't get your question clearly.
Sir, you said like that the discharge. I mean, the discharge valve should be open while using positive displacement pump, no, sir.
Correct.
If there is any emergency in the plant while plant running, or any fire in the hydrocarbon stream, for example, if you take any hydrocarbon stream, if there is any fire, means the stream should be closed, no, sir. So at that time, what we can what we can do, sir?
So generally what happens, a PSV is given. Suppose most of the always it is like nowadays it has become a standard to give a pressure safety valve in the discharge of a positive displacement pump, and that will go to the tank, suction tank or source tank, or it might again go to the pump suction line. Second option is you should give a sequence to start the pump in auto. right? So one is the recirculation line, one is the discharge line. So if you want to close, if suppose the discharge valve is closed, or you can say discharge XV is closed for any reason, then your recirculation line XV will open, right? So anyways, you will not you will not block the discharge anyway. Or you can give, suppose if your discharge valve is closed for any reason, then pump will stop. Or you can give an interlock in such a way that your pump will only start if your discharge valve is open, right? If your discharge valve is closed, then your pump will never start. So you can give an engineering control like this.
Okay, sir. Okay, sir. Thank you.
Hello, sir.
Hello, sir.
Yes.
Sir, are you
I
talking
have-
about
Yes, आपका आवाज नहीं आ रहा है.
hello, sir?
Sir,
हाँ बोलिए.
Am I
hello.
audible?
Just I have a question about if I have a caustic and I want to pump a caustic. So, what the kind of the pump is proper to use?
So for caustic, what is the percentage of caustic?
30%.
Okay, 48% caustic. Then you can use a centrifugal pump, not an issue.
Okay, thank you.
Okay. So when we talk about the pump curves, so there are four different categories. Basically, head is there, efficiency is there, power, and NKSH, right? So we'll see how all these vary with respect to the flow rate, right? So first of all, can anyone tell me why always the vendor, right? He gives the pump head in meters, right? Why we never talk about the pump head in terms of kg per centimeter square, or in kilopascals or bar? Whenever we are talking about the pressure, it is always in kg, or it might be in
Because
different
it's
units.
rho GH, rho changes for liquid to liquid, but the H remains the same.
Correct. So basically, it is always the head, and it is a constant property. It will never change, right? So that's why it is basically called the head is given in terms of meter, right? So now let us discuss one by one. So first of all, it is the head. So on x-axis we have the flow rate.
Sorry to disturb you. Please repeat the same.
Sorry.
Please repeat the same that you have mentioned, that head is always mentioned in given in meter. Please repeat. I don't
Okay.
understand.
Basically, the pressure is rho gh, right? So even if your density changes, right, your head value, like a pump, agar aapko suppose there is a 30-meter pump, right? So that 30-meter head is a differential head, right? अगर आपका जैसे कि पंप है, right? Suppose your pump suction tank is at first floor, and your pump head is, suppose you can discharge up to 30 meters, right? So अगर आपका पंप का suction first floor पे है, तो first floor से 30 meters, it is basically the head is a differential head, right? From the first floor, if suppose your pump is pumping at 30 meters height, right? If you put at second floor, it will pump basically 30 meters plus whatever the distance is. So agar aap suction pressure, that is basically the discharge minus the suction pressure, that is the head. So it is always, it remains same for any type of pump, right? So agar aap usko suppose, if you are using a pump of 30 meter, then वो 0 से 30 meter भी pump कर सकता है, 30 से 60 कर सकता है, 60 से 90 कर सकता है, right? So that's why that head is always same. सपोज आप फॉर एग्जांपल आपने एक पंप है, राइट? यू आर यूजिंग दैट पंप फ्रॉम ग्राउंड फ्लोर टू 30 मीटर्स तक उसको पंप करना है, दैट इज अ वाटर. सो 30 मीटर्स इज नथिंग बट 3 केजी पर सेंटीमीटर स्क्वायर. तो आपको डिस्चार्ज प्रेशर कितना मिलेगा? 3 केजी पर सेंटीमीटर स्क्वायर इफ यू आर शटिंग ऑफ दैट पंप. लेकिन सपोज आपको 60 मीटर से 90 मीटर पंप करना है, सो यू कैन यूज दैट पंप, डेफिनेटली यू कैन यूज, बिकॉज आपका डिफरेंशियल हेड तो 30 है, 60 टू 90 आपको पंप करना है. बट इन दैट केस 90, जहां पे आप 90 मीटर आपको पंप करना है फ्रॉम 60 मीटर्स, so when you see the discharge pressure, it will be higher, it will be 9 kg. That's why this head is always mentioned in terms of meter. Clear?
Okay. Thank you, sir. Thank you. Not clear.
Okay. और जो किसी ने बोला कि rho gh it's constant, but it will depend. Sometimes what we do, we give the meter in terms of meter of that liquid, right? Meter of liquid column we say MLC. So if we are fixed कि हम वही particular fluid ही use करने वाले lifetime for that particular pump, right, then it is MLC. Otherwise we give a meter of water column. So अगर कोई fluid है जिसका, suppose I will ask a question, suppose there is a pump, right, which can pump 30 meters up to 30 meters height of a water column. 30 meter water column is the head. Now if my fluid is having density of 3000 kg per meter cube, then it will be only able to pump up to 10 meters, right? Is it clear?
इसका माइक ऑफ करो ना, माइक ऑफ करो.
Yes. किसका unmute है? Please mute yourself if you don't have any question. Okay. So basically, suppose again I will ask. Yes.
Actually, I haven't get the point about the earlier. I've told that about 90 and 60 meter, the concept of the pump pressure. Could you, my pardon? Could you repeat that?
Okay. So suppose there is a 30 meter head, right? So whenever we say 30 meter is the head of the pump, it is always the differential head, right? That is the difference between the suction and the pressure, suction and the
Pressure,
discharge.
yeah.
That is the
Actually,
amount.
you are telling about the pressure or a head that is mentioned over the pump plate. Huh?
Correct. Yes. Yes.
Yeah. Okay. 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 Proceed.
So if the pump is rated as 30 meter head, so what will do? Whatever is your suction pressure, it will boost your suction pressure, like it will boost the discharge pressure by 30 meters. So suppose you are
30 meters.
pumping from 0 meter, then it will pump up to 30 meters. Suppose if you are pumping, your suction is at 60 meters, then it will pump at 90 meters. So your total differential head will be 30 meters always for that particular pump, but your discharge pressure will be different, right? So that's why your pump head, it is basically given as 30 meters, right?
Okay.
Again,
So
head will depend on the density also.
Okay. Now I get it. So that may the suction pressure may be provided by some another pump. If it is a 60 meter height, so that 6 bar pressure, 6 kg pressure will be provided by the another, one of another pump. So totally at the discharge, you are saying that at the discharge gauge, the pressure will be shown at 9 kg,
Right.
yeah?
It might be 90 kg also.
Yeah, that's correct.
So that 6 kg suction pressure, that is just an example. It can be provided by some another pump, or what you can do is you can shift the pump, or sorry, you can shift the overhead tank up to the 10th floor. So वैसे भी आप anyhow you can boost the suction pressure. आप tank का height बढ़ा दो, right? So that can be done.
Depends the pump with the positive section or a negative section. Yeah.
Yes.
Okay.
So when we
Sir,
talk about the
thank
pump
you.
head, yes.
Hello, sir. I have the doubt in this regard. If we change the density of the fluid, then what would be the impact of the head defined in the for the pump?
Yes, so that's what I'm saying. So basically, my question is, if your density increases, then what will happen? Your rated head will reduce or increase. Can anyone tell me?
Decrease.
It will definitely decrease. Suppose 1 meter of water column, right? One kg of pressure. Suppose let us discuss in this way: 1 kg per centimeter square. It is basically 10.33 meters of water column, and it is equal to 760 mmHg of mercury, right? So now density of mercury is 13.6 times higher than the density of water, right? So as the density has increased, what happens? 1 kg per centimeter square is equal to 10.33 meters of water column. It is equal to 760 mm of mercury. So suppose there is a pump, right? Suppose I am telling that it is 10 meter of water column of pump. Uska 10 meter head hai. So if I'm using water, then it can pump up to 10 meters. But if I'm using mercury, it will pump only up to 760 mm, because mercury is very heavy. The density is very heavy, right? So it is very high. So that's why it will not be able to pump the mercury. So now what is the reason it won't be able to pump the mercury? It is the power, because density of the mercury is very high. So it is not getting that sufficient power, right? That's why it will not be able to pump the mercury up to 10 meters, right? So if your fluid density increases, your power consumption will increase. So your pump will not be able to discharge up to the defined head. And if your density, suppose it decreases, then your head will increase in that case. Clear?
Okay, head will increase or the discharge pressure will differentiate. Like if we already purchased the pump which is have a constant head, in that case, if we decrease the density of the fluid, then discharge pressure should be changed, na? Not a
Head will be constant. Head is the property of the pump. So head will be
yeah.
constant, but your discharge pressure will increase. I'm sorry. Head will be
But
constant. Head for any pump will always be constant.
but before this discussion about in case of the mercury, you are saying that this will the head of the pump will change. So what is the correct? Actually, I
So
am
head of the pump will not change with respect to density. Like
oh,
I'm saying, your pump will not able to pump out. That is the reason. Like suppose 10-meter head is the rated head of a pump. And if I'm pumping the mercury, then your pump will not able to pump out. See, head has nothing to do with the density has nothing to do with the head of the pump. It is linked with the power. So ultimately,
if suction pressure is increased, then head will be increased.
Sorry.
no.
If suction pressure is increased,
No.
If
No.
we increase suction pressure.
Yes. So basically, if you increase the suction pressure, then your discharge pressure will increase, but head will always be constant.
But
Head
if we
constant.
change the fluid, then in that case, what would be happen with the head? That is my
Even if you
question.
change the fluid, the head will be constant.
Head
See,
will be
suppose what I tell you is the head is the property of the pump, right? And if you change your head, your suction pressure, discharge pressure, pipeline size, any changes you do in the plant or any changes you do with the fluid, head is always constant.
okay.
Clear? Head is
Now
always constant. So when I'm
okay.
saying 10 meter of water column, so it is basically 760 mm Hg. So what is the unit of that meter? That is significant. A meter of water column or meter of mercury column or meter of that liquid column. Clear?
Okay. Now clear. So basically, if we change the density and other property of the fluid, then the discharge pressure would get changed.
Yes,
I am
discharge
right.
pressure will definitely change.
Yeah. Okay. Fine. Thank you.
But head will be always same, right?
Yeah. Got it. Thank you.
So before I said na head will change. So basically head, in case suppose you convert the discharge pressure in terms of head, then it will change, right? आपको अगर
Right.
mercury pump करना है, then it will be taking 760 mm of Hg. That meter of mercury will be lesser, but still when you convert it, it is again always 10 meter of water column only, right? अगर आप for example if you are
So,
pumping
sir,
water using 10
basically,
meter pump, yes.
so basically, what we are saying is like, what will be the discharge pressure if we convert that in terms of header? That is the meter of liquid column of that fluid. That will be
Yes,
less, right?
yes,
Correct, na?
Okay.
yes.
Right.
Yes. So अगर आपका pump है, suppose you are purchasing a pump and you are saying that I will be pumping this particular fluid. So that meter of liquid column is with respect to that particular fluid only. So if the fluid changes, in that case, this meter of liquid column might change, right? So suppose if I am buying suppose there is a pump 10 meter of water column. So it is fixed. It is 10 meter always. It is 10 meter of water column. So if I pump mercury, then with respect to mercury, that head will be 760 mm Hg. So the value is changing with respect to unit also. But head, if we convert 760 mm Hg of mercury, that is again 10 meters only in terms of water column. Correct?
If I am getting right, you are actually saying that if I pump water and mercury, so if I pump a water about 10 meter, then 1 kg pressure will be shown by the pump discharge gauge, and
Correct.
same pressure will be shown by the mercury. I'm using the mercury, but it will be transferred up to 760 mmHg. Am I right?
Correct. Yes, yes. So it will again show 1 kg pressure. 760
Yeah, it
mm
will
is
again
1
show the
kg
1
pressure.
kg pressure.
Lekin it will be lifted up to 760 mm of mercury only. It will not be able to discharge that mercury at higher heights. Is it clear?
Yeah. I'm getting.
But in short, what you need to remember is that head is always constant. It will never change. The value is always fixed. The unit is always fixed. Correct?
So actually, the pump supplier will be supply the head in term of the specific liquid. So he is
Yes.
specifying the pump head for base of that liquid. It's
Yes.
up to us while we changing the its uses or type of fluid we using. The head will be revised. We must say that, no? I can say that the head must be
No,
revised over
head,
the table.
head will not revise. Basically, the head of the pump is always fixed. It will not be revised. Your discharge pressure will change, right?
Discharge pressure. I'm saying about the discharge pressure. Okay.
Yes. So suppose I am pumping water right now, right? So that is
Yeah.
10 meter of head. So suppose there is a low density fluid. Ziska density specific gravity is 0.5. So in that case, my
Hmm.
discharge pressure will be doubled, but head will be
Double.
same only, right? So
So
क्या होगा
head will be
10
same.
मीटर का
Head will be sorry. Head
that's
will
what
be
I'm
same
saying.
in term. Okay. Okay. In term of the density of that fluid that I have
In
altered.
terms of density of that fluid, it might. So suppose 10 meter water column hai, what will happen if the specific gravity is 0.5? It will be 20 meter of that liquid column,
Yeah.
right?
Yeah.
Ultimately it is same. 10 meter of water column, it is equal to 760 of mercury. It is equal to 20 meter of
नहीं
fluid which is having specific gravity of 0.5.
no.
Correct? Clear now?
Yeah.
So if you change the unit of the head, then head will change. Suppose मैं 10 meters of water column बोलता हूँ, it is again always 10 only. But if I convert that unit to of mercury, then it becomes 760. Clear? But always your pressure will never change. जबकि आपका जैसे कि पंप का डिस्चार्ज प्रेशर है, suppose there is a 30 meter head का pump. If you are pumping from 0 to 30 or 30 to 60, what happens there? Your discharge pressure changes. कभी 3 kg हो सकता है, 6 kg हो सकता है और 9 kg भी हो सकता है. Because you are increasing the suction pressure. And the head is basically the total differential head. So head is always same. Discharge pressure might change, right? Clear? So head is always same with respect to the unit with which the vendor is providing. अगर vendor ने बोला 30 meter of water column, for the lifetime that pump will always pump up to 30 meter of water column only, right? Clear now?
Okay. Okay.
Okay.
सर हेलो
Yes.
सर यहाँ पे जो भी पावर है वो यहाँ 0 से स्टार्ट होना चाहिए ना सर?
Yes, agree. Let us discuss. उसके बारे में आते हैं. So I think all your questions are clear. We will move to the pump curves, right?
Yes, sir. Please go
Okay.
ahead.
So first of all, we will discuss the power, but let us start with the head, right? So basically, on your x-axis we have the flow rate, on y-axis we have the different variables. So when your flow rate is 0, right? So pump is operating at shut off. आपका discharge valve close है, तो क्या होगा? All your velocity head, right? It will be showing the pressure. Now there are two types of pressure. One is a static pressure, one is a dynamic pressure. So static pressure is basically the pressure acting on the walls of the pipeline, or dynamic pressure is basically the pressure which is getting converted in terms of velocity, right? अभी आपका यहाँ पे क्या है? Static pressure. This head versus flow rate is in terms of static pressure. So what is happening? आपका सारा का सारा pressure at shut off condition, your head is getting converted into static pressure. सारा का सारा pressure is acting on the walls of the pipeline. So now as you start opening the valve, what will happen? Your fluid flow will start. So what is happening? The pressure will be released and all your pressure will get converted into dynamic pressure, that is in terms of velocity. So what happens? Your pressure head reduces and gets converted into velocity head. So your fluid starts to get some momentum, right? So your velocity is increasing with respect to flow rate. So जैसे जैसे आप वाल खोल रहे हैं आपको फ्लो रेट मिल रहा है और आपका हेड कम हो रहा है. So that's why at shut off you will be showing higher pressure. जैसे आप वाल ओपन करते हो आपका shut off pressure जो था पहले ज्यादा था वो pressure drop हो जाता है, right? It is getting converted into velocity head. So that's why this is the head and the flow rate curve, right? So suppose I have a question. Suppose this is a head and the flow rate curve. अगर मैं सक्शन का पाइपलाइन या डिस्चार्ज का पाइपलाइन चेंज कर देता हूँ, राइट? और सपोज सक्शन टैंक का हाइट और डिस्चार्ज टैंक का हाइट भी चेंज करता हूँ, will this head and flow rate curve change or it will remain the same?
Same.
Yes, so it will always remain the same, right? So what will change? वो होगा आपका सिस्टम कर्व. सिस्टम कर्व will change. So हम देखेंगे सिस्टम कर्व क्या है. So pump curves are always constant. So the next one is the efficiency, right? So when we talk about the efficiency, right? So at zero flow rate, what is happening? Your efficiency is zero, right? So what is the efficiency? It is the ratio of work done by the pump, that is the hydraulic power, divided by the power supplied to the pump, right? That is basically the electrical energy. So जब भी आप power देते हो pump को, what happens? That power is getting converted in terms of some work done by the pump. That is the hydraulic work by the pump, or you can say the hydraulic efficiency, right? So आपको power से कुछ flow मिल रहा है, but when your discharge valve is closed, so what happens? Your flow rate is zero, but still your pump is running at shut off. आप pump को कुछ energy तो दे ही रहे हो, right? So that's why power zero से start नहीं होता है. जब भी आपका pump का flow rate zero है, आपका discharge valve full closed है, so इसका मतलब ये नहीं कि उसको power नहीं चाहिए, उसको कुछ मिनिमम पावर चाहिए, राइट? सो जब भी आपका पंप आप स्टार्ट करते हो बट योर डिस्चार्ज वाल इज क्लोज, सो दैट इज द मिनिमम पावर इट इज ड्रॉइंग during the shut off. So that's why the power curve starts from this particular location. Clear? So now when your flow rate is zero, what does it mean? Your pump is delivering no work, कुछ काम कर ही नहीं रहा है. There is no hydraulic work done by the pump. That's why your hydraulic power is zero, but your pump is drawing some power. That is some input. So efficiency is basically ratio of hydraulic power divided by the electrical power. So once your hydraulic power is zero, your efficiency will be zero. So once you start increasing the opening of the discharge valve, your flow rate you will be getting. So your hydraulic power will increase. So up to a certain point, you will achieve the maximum efficiency. But after this particular point, your efficiency will drop, right? So generally, most of the pumps gives you efficiency somewhere around 60 to 75%, right? But after certain level, if you increase the flow rate, there is a drop in efficiency. कोई बता सकता है why this drop in efficiency after certain flow rate? Yes.
It crosses the best efficiency point of the pump, sir.
Correct. So after crossing that best efficiency point, why that efficiency is dropping? What is the reason? Yes.
सर ड्यू टू एयर.
Sorry.
सर उसमें प्राइमिंग हो जाता है.
No. So basically what happens at higher flow rates, what happens? At higher flow rates, your velocity will start increasing, right? And what will happen? Because of higher velocity, your Reynolds number will start increasing. At higher Reynolds number, at higher velocity, your frictional loss will start increasing. So what will happen at higher flow rates? Your pump will not be able to deliver properly. Your efficiency of the pump, the some amount of power, right, of the pump will be used to overcome the head losses. यहाँ पर क्या हो रहा है? Initially आपका power zero है, efficiency zero है, because some of the power is utilized in just starting the pump. So as soon as you open the valve, your power is used. Some of the power is used to flow rate for the flowing of the pump, plus to increase the head of the fluid, right? Power के calculation में क्या क्या आता है? Head, density and the flow rate, right? So the power is used here to increase the flow rate and increase the head. But after certain point, if you increase the flow rate, then what will happen? Because of the higher frictional losses, most of the amount of the energy of the pump will be going to increase the head, right? So in that case, जैसे आपका head बढ़ता है, right, your frictional loss will increase, right? Because at higher frictional losses, your head will be increased, right? So because of that, the efficiency reduces with respect to certain point. So इस point को हम बोलेंगे BEP, that is the best efficiency point, or this particular area is called the sweet zone, right? After beyond this sweet zone, your efficiency will drop. Is it clear, everyone? समझ में आया?
Sir, but after the sweet spot, head is also decreasing.
So this is the head, because of this is the head of pump versus flow rate versus head curve, right? This is different, right? ये head मतलब fluid का head है. What I mean to say is, suppose if you are increasing the flow rate, then what will happen? आपका flow rate जैसे बढ़ रहा है, then your frictional losses will increase. अभी up to certain point, if you want to increase that, आपको at higher flow rate, what will happen? Your head losses will increase, right? So that's why this efficiency drops after a certain.
Okay.
Sir,
Okay.
here it is basic flow rate,
Sir,
discharge flow rate.
sir, like is it sir, is all the pumps do operate at the best efficient point, sir, or there will be some variation, sir?
So most of the time, ideally, we should always operate your pump at BEP or near the sweet zone. But almost most of the time, it does not operate. So it operates somewhere around 50 to 55 or 60% of the efficiency. But you should not never use a throttling. You should never use your pump in the throttling service. You should never throttle your pump.
Sir,
Sir, here it is
And sir,
basic flow rate, discharge flow rate or
the reason, sir.
Reason for throttling, we will see a case study. There we will see why should we not use a pump in throttling.
Okay, sir.
That point will be clear, and this efficiency why it is reducing, that will also be clear. I will answer that in the second half. After 20 minutes we will see that case study why we should not throttle the pump. Okay.
Sir,
best
sir, I just want to ask one question. This head curve is also same for the positive displacement pump also?
No.
No, it will be different for the positive displacement pump. There you will be having a peak. It will not like ऐसा नहीं रहेगा. At higher flow rate it will be comparatively flatter, right? यहाँ पे क्या हो रहा है, आपका head reduces with respect to flow rate, it will be flatter. वो flat रहेगा.
Okay. Thank
You can just
बेस्ट एफिशिएंसी
मिल जाएगा.
के बाद भी आने पे पावर पे क्या इफेक्ट पड़ेगा?
Sorry.
बेस्ट एफिशिएंसी जहां पे पॉइंट है उसके बाद भी मैं फ्लो बढ़ा रहा हूँ, फ्लो रेट बढ़ा रहा हूँ, उसके बाद पावर पे कुछ इफेक्ट पड़ेगा, कम होगा, बढ़ेगा या
Definitely
कांस्टेंट
आपका
रहेगा?
power बढ़ेगा. See, your flow rate with respect to flow rate, your power is always in the increasing trend. So मेरा वही है कि why this efficiency drops out at certain point. पहले आपका जो power था, your frictional losses at lower flow rate were comparatively not dominant. आपका जो भी power था, that power was consumed to increase the flow rate and to increase the head. But after a certain point, what happens as your flow rate increases, right? So as your flow rate increases or आपका velocity starts increasing at higher flow rate, so significant amount of frictional losses are created. Now up to before the sweet zone, right? Before this BEP, your frictional losses were not dominating. But after this certain point, after the BEP point, your frictional losses starts to dominate, and because of that most of the power is utilized to overcome those frictional losses. But when we talk about the power with respect to flow rate, it is always increasing. As your flow rate keeps on increasing, your power consumption will keep on increasing. Mostly the power versus the flow rate is always linear. Power versus flow rate curve is always linear. So यहाँ पे क्या है, जैसे आपका फ्लो रेट बढ़ता है पावर कंजम्पशन बढ़ता है, बट विद रिस्पेक्ट टू एफिशिएंसी, राइट, इट इज व्हाई इट इज श्रिंकिंग, बिकॉज पावर तो आपका लीनियर है, लेकिन हम जब फ्लो रेट बढ़ाते हैं पावर कंजम्पशन लीनियर है, लेकिन व्हाट हैपेंस that linearity is not maintained, because of that your efficiency curve shift. For example, if I say at 10 meter cube of flow rate your power consumption is 10 kilowatt, at 20 meter cube it will not be 20 at 20 kilowatt it will not be 20 meter cube per hour, it will be lesser because your efficiency is lesser. So
ये
your
efficiency
power
कम होता
versus
है
flow
केवल
rate curve is linear but efficiency will
सेंट्रीफ्यूगल
drop.
पंप में या पॉजिटिव डिस्प्लेसमेंट पंप में?
Sorry,
एफिशिएंसी जो कम हो रहा है एक सर्टेन लिमिट के बाद, इवनली सेंट्रीफ्यूगल पंप में कि पॉजिटिव डिस्प्लेसमेंट पंप रहेगा उसमें भी होगा?
see this is with respect to centrifugal pump only. See रेसिप्रोकेटिंग पंप में इट इज ऑलवेज लीनियर. आप जैसे फ्लो रेट उसका स्ट्रोक बढ़ाओगे वैसे पावर कंजम्पशन ज्यादा चाहिए. उसमें तो आपका पिस्टन के स्ट्रोक पे है. As you increase the flow rate, right? Similarly, this effect will also come with respect to reciprocating pump, right? But that curve will be different.
Okay.
Okay.
But the same situation will be happened in the positive displacement pump also, na? If we used to increase the flow, same time the friction losses will
Yes,
be
it will
increased
happen.
inside
It
the
will
pipe.
happen. Yes. But that yes, definitely there in a centrifugal pump also there is some best efficiency point, right? But that like curve, nature of the curve will be somewhere different. यहाँ पे जो आपको दिख रहा है, suppose it is going up and going down, उसमें थोड़ा डिफरेंट आएगा. So basically the fundamentals are same even for the reciprocating pump, PD pump, positive displacement pump. After a certain point your efficiency will reduce.
Okay, okay, okay.
Okay, so with respect to power, you can see your power curve is linear, right? So with your flow rate your power consumption will increase, right? The next and the last one is the NPSH required. So basically NPSH required is the minimum suction pressure that we need to maintain in order to avoid the cavitation of the pump, right? So again you can see after this BEP point, right? Once this BEP point passes, your NPSH requirement increases. Why it increases? Because at higher flow rates, again your Reynolds number increases, your frictional factor increases. So because of that, your frictional losses increase in the suction side, right? Efficiency पे जो impact आ रहा है, it is because of the frictional losses in the discharge. NPSH required पे जो impact आ रहा है, it is because of the frictional losses which has increased in the suction side. So at higher flow rates, your NPSH requirement increases because at higher flow rates, your frictional losses increases in the suction side. Clear? That's why this is NPSH required increases at higher flow rate. Clear?
Sir.
Okay. हाँ बोलिए.
Hello, sir.
Yes.
Sir, I'm having a doubt.
Yes.
Sir, what's the difference between the PD pump curve and centrifugal curve?
Sorry?
How will you differentiate between the PD pump curve and the dynamic pump curve, sir?
If you check it out, it is. Sorry?
So is there any differentiation between PD pump curves and dynamic pump curves, sir?
See, dynamic pump, when we say dynamic because you are able to get multiple flow rates, right? Suppose when we talk about this particular, so at this head you are getting this much amount of flow rate, at this particular head you are getting this much amount of flow rate. So with the centrifugal pump, why it is called dynamic? Because you can have multiple different flow rates, but that is not the case with the PD pump, right? Your PD pump will be always operating at fixed pressure and fixed flow rate. Nowadays, like what you can do is you can adjust the stroke, right? By that you can increase or decrease the flow rate, but it is basically a constant flow rate pump. PD pump cannot be used for different flow rates. You are basically increasing or reducing the stroke, right? आप क्या कर सकते हो? Suppose आप centrifugal pump, like someone will tell we are able to increase or decrease the flow rate in the PD pump. No, that is not the case. We are increasing or decreasing by increasing the stroke length, stroke number of strokes, because we are changing the stroke, basically number of strokes per unit time. Suppose हम डायनामिक पंप में क्या करते हैं, हम वाल्व को थ्रोटल करके फ्लो रेट कंट्रोल करते हैं, राइट? वी आर नॉट चेंजिंग द आरपीएम ऑफ द पंप, राइट? सो बेसिकली पीडी पंप में आप एट पर्टिकुलर स्ट्रोक लेंथ, स्ट्रोक पे आप फ्लो रेट चेंज नहीं कर सकते. That's why it is called a constant flow rate pump. Clear?
Yes, sir. Yes, sir.
I hope it is clear.
Sir, I think we can change the flow rate in positive displacement pump with the help of variable frequency drive.
See, variable frequency drive, definitely you can do that. What will variable frequency drive do? It will basically again change this number of strokes per unit time. It will change basically the rotations, but at particular fixed rotation you cannot change the flow rate, correct?
Yes, that is right.
So that's why आप अगर आप उसका कर्व देखोगे, it will be basically a flat straight line only. PD pump का जो कर्व है, basically we are talking just on this centrifugal pump. That's why if I will be having a PD pump curve, so if you check that, so it will be a straight line, right? It is a constant flow rate.
Okay. So you mean to say at a particular number of strokes we cannot change the flow rate? It will be same.
It will be same. Always it will be same because एक 10 strokes आपका piston 10 times per minute में up and down होता है. So what will happen? What will be the flow rate? वो जो पिस्टन का जो एरिया है, जो वॉल्यूट, जो उसका केसिंग का जो एरिया
सकता है वो उतना ही पंप करेगा,
उतना ही डिस्प्लेस कर पाएगा. अगर आप उसका टाइम चेंज करोगे, इफ यू पंप दैट वेरी क्विकली, उसका पिस्टन का अप एंड डाउन का टाइम cycle if you change,
flow
then
rate will
definitely your
also.
flow rate will change. But at
Okay.
fixed stroke per minute, your flow rate will always be constant. Whereas
Okay.
that is not the case. हम VFD centrifugal pump में भी लगा सकते हैं,
Yes.
right?
Yes.
But by throttling the discharge valve at a, आपका VFD का पंप नहीं है, normal pump है, but by throttling the discharge valve, by using a control valve, you can change the flow rate with respect to centrifugal pump. But that is not the case with PD pump, correct?
Yes. Okay. Thank you. Thank you, sir.
Okay. So moving ahead, so we'll see some of the case studies, right? Okay. So we will see what is basically the system curve, right? So suppose basically what happens when your tank is there. This is a suction tank, this is the pump. So there is some suction head, right? So what is this suction head? That is nothing but the head that is created because of the fluid which is in the suction tank. So that is the suction head. Okay. So now these are the system curves, right? So what is the system curve basically? So with respect to head and the flow rate, right? This is called the system head and flow rate curve. So this is static head. So static head is the head because of the fluid in the suction, and this is the friction head. So जब आपका fluid है, suppose you're at this particular point, I will just show. So suppose at this particular point, what is happening? Your flow rate is 0, right? And your discharge valve is fully closed. So what will happen? Whatever the head is, all because of the suction head, right? As now you open the discharge valve, what will happen? Your fluid flow will start, right? And your system curve, right? It will generate some pressure. This pressure is because of the friction, right? So this is the entire, this is because of the friction. So आपका ये है pump system का curve. So how your system is behaving. So if you shut off the valve, then what will happen? It will be over here, right? So the point at which your system curve will intersect your pump curve is called basically the pump operation point. Is it clear? What is basically the friction head? So friction head मतलब क्या है? जब भी आप पंप का डिस्चार्ज वाल्व खोलते हो, so what will happen? Some of the head, it will be basically the friction head, right? आपका क्या हो रहा है? Someone will say, sir, flow के साथ तो head बढ़ रहा है. So it is because of with higher flow rate, your friction head is increasing because of the Reynolds number. So you will see, just a minute, I will show you with respect to intersection, right? So this is basically the head and flow rate curve. So this is the property of a pump. This curve will never change. Whereas this is the system curve. So that is the property of the system. That is the setup, our plant, right? So intersection of both this is called the pump operating curve, right? So suppose this is the system curve. So why this is the gap? Why this gap is? This gap is because there is some static head, right? आपका पंप का सक्शन टैंक के बॉटम से और टैंक में इतना लिक्विड भरा हुआ है, right? This is the meter height, or you can say head, because of the water level in the suction tank. Now as you increase the flow rate, what will happen? Your system curve is changing. Suppose I throttle the valve, मैंने valve को 100% की जगह पे सिर्फ 5% ओपन रखा, then what will happen? The system curve will be like this. आपका system curve कैसे होगा? यहाँ से सीधा ऊपर चला जाएगा, right? So your pump operating point will be somewhere here. So अगर मैं पूरा valve खोल दूंगा, तो what will happen? My system curve will shift towards the right hand side. अगर मैं वाल्व क्लोज करता जाता हूं, तो व्हाट विल हैपन? माय वाल्व विल कीप ऑन क्लोजिंग और मेरा सिस्टम कर्व इस तरफ मूव होके अल्टीमेटली शट ऑफ में चला जाएगा. इज इट क्लियर नाउ? नो? ओके, so let us see one case study with respect to system curve, right? So what is the case study? I will repeat.
Sir, one small
Yes.
Sir, does all the pump operates at the operating point only, sir? There may be any deviations a little bit. That's all the pumps, not only ideal, all the real cases also, sir.
So there is a lot amount of background noise. Can you please repeat?
Sir, does all the pump operate in the exact operating point, sir, or does it deviate a little bit?
It definitely deviates from the operating point. You can have multiple operating points. That's what I said is basically, suppose this is your system curve. This one is the head and flow rate curve, right? That is the property of the pump. This will never change. It is always constant. But with respect to your system curve, if you open the valve, close the valve, right? So your system curve will keep on changing. That's why your operating point will change. Suppose this is the system curve, that is the how your pump is performing. Suppose if you throttle the valve, then what will happen? Your system curve will move towards the left hand side, और वो discharge में चला जाएगा. Suppose if you open 10%, then it will be somewhere over here. At 20%, it will be somewhere over here. At 30%, it will be somewhere over here. So suppose now it is 60-70% your valve is open. Discharge valve is 70% open. That's why it is here. Suppose if my open the valve full open, right? If I open the valve 100%, then it might shift over somewhere here. So your flow rate is increasing, right? So your system curve is basically changing, and the intersection of the system curve and pump curve is called the operating point. Is it clear now?
Okay, sir. Okay, sir.
Okay, we will see one case study. After that, everything will be clear with respect to efficiency, pump curve, system curve, everything will be clear, right? So please, I will request everyone to please pay attention. This is a very, very good case study. So suppose, basically what I said, pressure losses, as mentioned earlier, pressure losses are there, which has to be overcome by the pump. So first of all, first reason is, why do we require pump? We require pump to overcome the pressure losses, right? Suppose your pump is at ground floor, and if you want to fluid the pump to the third floor, then we will not just require that differential head. आपको ground floor से third floor, suppose each floor is of 6 meters, then pump of 18-meter head is not just significant, right? We should also take into account the frictional losses, right? So there are some pipelines, we have to overcome those frictional losses. So that's why we have pumps. So basically the primary function of the pump is to overcome the frictional losses of the system, right? So what will happen? So let us see the case study, right? So first of all, I will repeat basically what is happening, right? So basically this is the case study of why should we not use a pump in a throttling service, right? What is the effect of oversizing of the pump, and why should we not use the pump in a throttling service? So whenever you are sizing the pump, you should be very thorough with your operating point, because if you will deviate from your operating point, then your efficiency will keep on changing. It will differ from the best efficiency, and there will be significant amount of power losses, right? So suppose we have now we have a estimated our system operating condition as 500 meter cube of flow rate and 50 meter of head, right? So 500 meter cube per hour of flow rate and 50 meter head is our desired operating point, right? That is our desired flow rate and head we want, right? So we will choose a pump curve which intersect the system curve point A at the best efficiency point, right? So suppose this one, right? This is the system, this is the head in the flow rate curve. This one is the head in the flow rate curve. Okay. So now we will select a system curve in such a way that at point A we will get the best efficiency, right? So this point A is the our operating point at 500 meter cube per hour of flow rate, and 50 meter is the head, and efficiency is 82%, right? So at point A, what is the pump curve, head versus flow rate? This black one is the pump curve, and it is operating the system curve at this particular point, that is the point A, and our system curve is a green one. Initially it is a green one, right? So now what happens? Now we will choose a pump which intersect the system curve at point A at the best efficiency point, right? But in actual operation, we came to know that 300 meter cube per hour is sufficient. Now we are telling that we don't require 500 meter cube per hour, we just require 300 meter cube per hour. So now what will happen? Simple question is, if you want to reduce your flow rate, what will you do? क्या करेंगे आप?
Valve throttle कर देंगे.
Correct.
Valve
So
throttle.
what you will do, you will throttle the valve, right? So what will happen at that point? So if you throttle the valve, right? So suppose you want 300 meter cube of flow rate with the same pump, right? So black one, this particular curve where my cursor is, right? So this particular is the pump curve, and from point A at 500 meter cube per hour of flow rate and 50 meter of head, right? I want to shift to 300 meter cube. तभी मुझे ये pump पे 300 meter cube चाहिए, तो what I will do is I will shift to point B. So now at point B, what is happening? I am getting 300 meter cube of flow rate, right? But my head has increased, my pressure has increased because I have throttled the valve, right? आप पंप के डिस्चार्ज को थ्रोटल करते हो तो क्या होता है, आपका डिस्चार्ज प्रेशर बढ़ जाता है, करेक्ट? और जैसे ही आप वाल्व को ओपन करते हो तो क्या होता है, योर डिस्चार्ज प्रेशर रिड्यूसेस, right? So now as my flow rate has reduced, my head is higher, 70 meter is there, right? So what is happening at point B, my efficiency is reduced up to 77%, previously it was 82%. So why my efficiency had reduced at 300 meter cube flow rate and 70 meter head, कोई बता सकता है मेरा efficiency क्यों कम हो गया?
Sir, the motor is delivering the constant power, but the hydraulic power that is generated, the hydraulic power that is generated is less than compared to the hydraulic power generated in the previous case. So hydraulic power by the input power given, output by input gets reduced, so efficiency is lowered.
Correct. So basically what is happening, your flow rate versus power curve, it is always a straight line, it is linear. But previously what was happening, at point A your valve was full open, the discharge valve was full open, that's why your efficiency was 82%. Now your discharge valve at point B, it is in throttle condition. So what is happening, your efficiency difference is 82 minus 77, so 5% drop in the efficiency. So that particular drop in the efficiency, that amount of power goes into overcoming the resistance that is provided by the throttling of the valve. आपका वाल्व क्या कर रहा है, throttle कर रहा है, right? So what is happening, because of that throttle condition of the valve, I have to overcome that frictional losses ना. जब मैंने पंप को डिजाइन किया होगा तब मैंने क्या किया होगा, तब मैंने दिखाया होगा कि 500 मीटर क्यूब और 50 मीटर हेड के लिए मुझे चाहिए. So at that time the valve will be full open. So now what is happening, I am throttling the valve. So in order to overcome that resistance because of the throttling of the valve, I have to give comparatively more power. That's why my hydraulic efficiency reduces. That's why my efficiency dropped from 82 to 77. So now currently from point A, I shifted to point B because आपका पहले क्या था, static head, tank में liquid level का height is same. But initially my system curve was operating at point A. It was intersecting pump curve at point A because my valve was full open. So now by throttling, what I did, I shifted at point B क्योंकि मुझे कितना 300 मीटर क्यूब पर आवर का ही फ्लो रेट का रिक्वायरमेंट है, राइट? प्रीवियसली माय पंप वाज डिजाइन्ड फॉर 570 मीटर हेड, but now I required only 300 meter cube. So in order to reduce the flow rate, I have to throttle the valve. Now what will happen? Now in actual, we find that 300 is sufficient. So reduction in the flow rate has to be affected by throttling the valve. In other words, we are introducing an artificial resistance in the system, right? So we have to overcome that resistance. आपका throttle valve मतलब क्या है? It is a resistance. It is an obstacle in the flow rate, right? तो उसको overcome करने के लिए आपको कुछ energy देना पड़ रहा है, right? अगर आप suppose there is a pipeline, आपका डिस्चार्ज का पाइपलाइन एक है 4 इंच का है और एक पाइपलाइन है which is very less, suppose that is 1 inch, right? So what will happen in the 1 inch pipeline, your frictional losses will be very high because your velocity will be higher, right? So in that case what will happen, your power consumption will be higher, right? So that's why your efficiency will be reduced with respect to 1 inch pipeline. So यहाँ पर क्या हो रहा है, आपका वाल्व थ्रोटल है, मतलब एक तरीके से आपका लाइन साइज कम हो रहा है, वैसा ही है. So that's why you have to overcome that resistance at the loss of some frequency, at the loss of some efficiency, right? So now due to this additional resistance, the frictional part of the system curve increases and thus the new system curve will shift to the left hand side, which is the red one, right? So now the pump has to overcome the additional pressure, right? उसको क्या करना पड़ रहा है, वाल्व जो थ्रोटल है उसके कारण वो प्रेशर को ओवरकम करना पड़ा. So pump has to overcome the additional pressure to deliver the reduced flow rate. Now the new system curve will intersect the pump at point B. The revised parameters are 300 meter cube and 70 meter, right? So what is the revised condition? It is basically 300 meter cube and 70 meters, right? So B, what is happening? My efficiency had reduced, right? So you can note that efficiency point has shifted from 82% to 77%, right? So suppose मुझे फिर से मेरे efficiency point, best efficiency point पे आना है, तो मुझे क्या करना पड़ेगा? Suppose I want to shift to the best efficiency point. So my best efficiency point for the system lies at 82% on the green curve, right? So in order to shift from point B to point C, मुझे क्या करना है? सेम फ्लो रेट मुझे पहले मैंने डिजाइन किया 500 मीटर क्यूब पर आवर के हिसाब से, मुझे लगा 500 चाहिए होगा, लेकिन अभी मुझे मुझे पता से लग रहा है कि ओनली 300 इज सफिशिएंट. सो सपोज पॉइंट बी टू सी मुझे शिफ्ट करना है. सो व्हाट आई विल डू फ्रॉम द रेड कर्व एट पॉइंट बी आई विल शिफ्ट टू सी, राइट? पॉइंट सी मैंने शिफ्ट किया. सो
Can I play with the RPM or impeller size?
Yes, RPM और impeller size चेंज कर सकते हैं. एग्री 100% we can change the RPM. So RPM कैसे चेंज करेंगे? By using the variable frequency drive, or you can trim the impeller. That is the correct answer. But we are saying हमारा purpose of the case study is why we should not throttle the valve. आप throttle करके कितना नुकसान कर रहे हैं अपने पंप का, अपने पावर का. So that is basically the understanding of this case study.
Let's take a case study. In some situations, while we used to run the pump, after a certain time, if I'm not getting the suction properly, if I'm not getting the suction properly, then it is a normal operations in the refinery that we used to have throttle the valve, discharge valve, so that during the startup, I'll get the pressure.
So if you throttle the discharge valve for a short period, then it is not an issue. But for a longer period, if you keep on throttling the discharge and keep it as it is, then your pump will be operating at far away from the BP. So as such, pump में कुछ problem नहीं आएगा on longer period, but basically your power losses, your pump will not be operating at the BP. So basically आपको क्या करना है? जब भी whenever you are designing, make sure that your pump should always operate near BP. If it is deviating, basically, so it will lead to more power losses.
This is another case. If I have a controller in the discharge of the pump will be the valve opening will be decided by the control loop that I have provided over there. So for the case, let us consider that it is provided with the LCB loop. Control valve is provided with the level control. So the valve will continuously fluctuate as per the level.
Correct. So in that case, you should give a recirculation line. See, I request please one at a time, because multiple people, if you are unmute, then I will not be able to listen to the question properly. So you are saying, I think your question is, suppose your pump is there and your flow rate is continuously keep on changing because there is a control valve. So in that case, your system curve or your operating curve will keep on changing, right? So what you can do is you should give a recirculation line in that particular case. So what will happen? Using that recirculation line, always there will be some flow rate. Is it clear now?
Yes, sir.
Okay. Yes. Any other questions?
Please repeat, sir.
Okay. So basically your question was, whenever let me just answer, please mute yourself. Let me just answer. So once it is clear, I will take other questions also. So basically, whenever you are operating a pump, right? So your question was, your discharge line has a control valve. So your flow rate keeps on varying as per your requirement. So in that case, your flow rate keeps on changing. Your pump operating point will keep on changing. So in that case, what you can do is you can give a recirculation line, right? So whenever your discharge line control valve closes, then your recirculation line valve will open. So always you can maintain a fixed flow rate. Suppose I am given a task to always operate a point at best efficiency point. So I have identified best efficiency point is 100 meter cube of flow rate, right? So at 100 meter cube, if I operate my pump, then always my pump will be operating at best efficiency point. So what I can do, suppose my system requirement is 50 meter cube per hour. So I will pass 50 meter cube per hour flow rate in this system, in my plant, and 50 meter cube of flow rate will be passing through the recirculation line back to the source tank, right? So always my pump will be sending 100 meter cube, but it will be splitted in the plant as well as in the recirculation line. So always my pump will be operating at the best efficiency point. Suppose my plant requirement reduces to 20 meter cube. So 20 meter cube will be going inside the plant and 80 meter cube will be passing through the circulation line. Is it clear?
Can we design pump for the requirement of the process? So we did. So we didn't have that of the pump.
Because multiple people are saying I'm not able to listen to your question. Please, one at a time.
Yeah, sorry, sir. I am want to say if we design our pump for the requirement process, so in that we would able to design the pump in a right way.
Yes, if you know your requirement, then you should design that pump at that particular flow rates only. But it is a good practice if you give a recirculation line. So in that case, if there is any deviation, then it can take care for that.
Hello, sir. Hello, sir.
Okay.
I have one question.
Yes.
As you told earlier that we are providing 20%.
So actually,
we are providing 20% to.
Please, one at a time. Please, I request एक जन बोलिए. So please one at a time. If someone else is asking, so please mute yourself. I will take all your questions. Rahul, you can go with your question. Yes,
so
Rahul, if you have a question.
So I have to give you circulation and will be maximum of 2 meter cube. So once
your voice is not audible,
will be
Rahul.
provided.
आपका आवाज नहीं आ रहा है ठीक से.
Will be different. The gauge is showing.
प्लीज चेक योर नेटवर्क कनेक्शन. और मैं रिक्वेस्ट करता हूँ एट अ टाइम कोई एक ही क्वेश्चन पूछे प्लीज.
मैं बोलना चाह रहा हूँ.
Please check your network connection. Otherwise, I will mute both of you and
अभी आवाज आ रहा है.
Your voice is not clear.
म्यूट करके आगे चलाइए सर. आगे प्रोसेस कीजिए.
Okay. So please check your network and then only ask, because it is unnecessary. We are wasting lot amount of time.
Hello. Hello, sir.
Yes.
I have one question.
You can go. Yes, Abhimanyu, you can go ahead. बोलिए.
Yes, sir. Sir, as you earlier told about, we are giving 20% to main line and 80% to circulation line, but we are designing minimum circulation line up to 30% of the header line. So how can we give 80% to circulation line?
So yes, agreed. So suppose if you are, मैंने क्या बोला कि if I am given a task that always operate at BEP, then you can give any amount of flow rate in the recirculation line. But mostly as a standard, what we do is 20 to 25% of the desired flow rate is given in the circulation line, because we never want our pump to run in a total shut off. Recirculation line, agar suppose if I am given a task ki always operate at BEP, then I can divert any amount of flow rate. Suppose मेरा pump पूरा shut off में चला गया, 100 meter cube is the design flow rate, so all my 100 meter cube will go through the recirculation line. Generally हमारा generally we as a thumb rule we say 20 to 25% should divert in the circulation line. So because we never want our pump to operate in shut off, so 20-25% flow rate of the design flow rate will be somewhere around 35 to 40% of the efficiency. Clear?
Okay. Yes, sir. Got it, sir.
Just वो तो मैंने example basis के लिए बताया था.
Okay, sir. I have another question regarding circulation line, sir.
Okay.
Circulation line helps to reduce the temperature in a pump that's called the cavitation in the pump. So is it correct about the circulation line, sir? Can you help me to guide about circulation?
Circulation line reduces the temperature.
No, the heat generated in the pump. So we give a circulation line to each pump, minimum circulation line to each pump to reduce cavity to to help to reduce cavitation in the pump. Due to
Circulation line has nothing to do with the cavitation. There is no link between the cavitation and recirculation line.
okay, sir. Okay, thank you, sir. Got it.
There is no link between those two. Okay.
Or I have
Sir,
read
please go ahead.
anywhere regarding this.
Okay.
Okay, thank you, sir.
Sir, please go ahead.
Okay. So basically now what happens, I will shift from point B to point C. So now point C is lying on the green line. It means it is a 82% efficiency, but my head will be reduced, right? So you can see I'm getting 42-meter head at point C. So you can see at point C, my flow rate is same. Point B and point C, my flow rate is same, 300 meter cube per hour. But at point C, my head is 42 meters and at point B, it is 70 meters. So what is happening? Because of that closed valve, my requirement is 300 meter cube, but because of that closed valve, I have to overcome that 70 minus 42. So that amount of head is a delta because of the closed valve, right? So once I shift to the point C, what will happen? I will be operating at BEP. लेकिन point C पे तो मेरा pump curve तो दूर रह गया. My pump curve is this black one is a pump curve. Point A, point B, these are on the pump curves, but point C is not on the pump curve. So what I will do is at point C, if I construct a similar pump but with a lower diameter of impeller, अगर मैं impeller का diameter कम कर दूंगा, so my blue curve is the new pump curve with a lesser diameter, which is operating at 300 meter cube flow rate and 42 meter of head, which will operate at 82% efficiency. So what I did, right? So the pump has to overcome. Okay, that we saw. So now we want in actually to operate at point C, which is 300 meter cube per hour on the original system, and the head required is 42 meters, right? So now we will need a new pump which will operate at best efficiency point at C, right? So what we can do, the speed of the pump can be reduced or existing impeller can be trimmed with a new lower size impeller, right? So the blue curve represents the lower size impeller, that it is a new pump curve. So you can see how throttling a pump can reduce your efficiency, right? So suppose if you are throttling your pump, what it means, you are shifting away from the best efficiency point. And once you shift from the best efficiency point, then your power consumption will increase. So this is one of the example of throttling, as well as how wrong sizing of the pump or oversizing of the pump can damage your system. Let us see one other case study, right? So suppose in this case study, we require a 68 meter cube per hour of flow rate of water at 47 meter head, right? So there are different characteristics curve available, right? So you have A, B, C, D, E, 5 different curves available. So it means you have 5 different options, 5 different pumps you have. So out of which you have to select any one for your requirement of 68 meter cube of flow rate and 47 meter head, right? So now suppose this X, this point, these all are the best efficiency point on the curves. So suppose I select pump A for the 68 meter cube flow rate and 47 meter head. So what will happen? So for the point A, for the pump A, what will happen? Your 68 meter cube flow rate, right? It is somewhere over here. It is 68 meter cube flow rate and 47 meter head is somewhere over here. Suppose if I select pump A, then it will operate at 50% efficiency. So pump A will give me 68 meter cube per hour of flow rate, but it will give me 76 meters of head, right? So that is basically 50% of efficiency. And if I suppose select pump E, then what will happen? 68 meter cube per hour of flow rate at 47 meter head.
See any screen, sir?
Sorry?
We didn't see any screen. Your presentation.
Screen
sir.
is visible. Visible.
It is visible.
Yeah, the screen is visible. Just kindly restart. I mean, just join once again. It will be visible for you. It is just a technical glitch.
Okay. So what is happening at 68 meter cube per hour? You are getting 47 meter head, but you are getting 60%. That is the best efficiency. So we'll see. So if we select pump E, then efficiency is 60%, right? So if I am calculating the hydraulic power, that is 68 meter cube, 47 meter head, right? Density is 1000 for the water. So I'm getting 8.7 kilowatt of the hydraulic power. And what is the power that I will have to supply to the pump? That is 8.7 divided by 0.6, because 60% is the efficiency. So if I'm giving 14.5 kilowatt of power to the pump, then 8.7 is the effective hydraulic work. Rest 40 is the frictional losses. And my motor efficiency is 90%. So what is happening? If I am supplying 16.1 kilowatt of power to the pump, then 14.5 will be going to the pump, and then 8.7 will be the hydraulic work. So 16.1 supplied from the grid to the motor, then motor will consume 10% of the efficiency because of the heat losses and dissipation. And from the motor, 14.5 will go to the pump. Out of that, only effective 8.7 is going. So you can see generally half of the power gets wasted, right? So effective power is just 8.7 compared to the supply, that is 16.1. So suppose if I select pump A, right? Different pump curves are there. Suppose if I select pump curve A, so what will happen? This will be my operating point. I will get 68 meter cube per hour of flow rate, but my head will be higher, 76 meter. So you can see what will happen in that case. So 68 is the flow rate, head is 76. So you are getting 14 kilowatt as the hydraulic power. Your efficiency is 0.5. That's why your shaft power will be 28 kilowatt. And if you are using again the same efficiency motor 90%, then 31 kilowatt. So you can see what is the difference in power, right? Additional power that A is drawing, that is 31 minus 16.1. So 14.9 kilowatt is the extra power you are giving because of the wrong selection of the pump. That's why if you see per years, right, we have 8760 hours in a year, and 14.9 is the electricity cost per unit. Then generally you can see, you can just quantify, somewhere around 5 lakhs of rupees is the extra cost you are spending just because you have not selected a proper pump. So always you should select a proper pump, and even after the selection, you should never use a pump in the throttling service. Always use your pump at the best efficiency point, right? Suppose sometimes what happens, आपको flow rate का जरूरत नहीं है, right? So what you do is you throttle the valve, right? Even some companies, some organizations where engineering not is where there is not proper engineering, they are not providing the recirculation line. So in that case, what will happen? Your pump will be operating very far away from the BEP. So at least providing a recirculation line will help you to operate at somewhere around 40 to 45% efficiency. But without recirculation line, you will be operating somewhere at 20-25%. Okay. Is this case study clear, everyone? समझ में आया सबको?
Yes, sir. Yes, sir. Very good explanation.
Sir, like all the plants will be, I mean, all the plants will be having recirculation, I know, sir, for all the pumps.
Not all the pumps have recirculation line. Like it is very good practice to give recirculation line to all the pumps, but generally that is not the case with all the industries. Okay, is it clear?
Yes.
Okay,
yes,
sir. Okay.
Yes. One question.
Sir, apart from the circulation line, but are the another technical alterations, or there are solutions that industry there is present in the industry that we can done to run the plant over the BP, near over the BP?
Other than this, what you can do is, suppose what happens, like it is not always useful. Recirculation line is a universal basically solution. Sometimes suppose we are circulating hot oil, right? Suppose when I talk about my particular plant, so we are circulating hot oil to a exchanger, and again that hot oil comes back to the return tank, right? So suppose if I don't require any hot oil, what I will do is, one control I will give in the supply, another control valve I will give in the bypass line. So whenever there is a, suppose my temperature has reached in the exchanger, right? So what will happen? My bypass valve will open and my inlet valve will close. So in that case, my flow rate will be there. Pump will be always operating. So all my flow rate will be going in through the bypass of the heat exchanger and again coming back in the tank, right? So in that way I can do. Again, bypass line is nothing but again acting as a recirculation line only. So that is one of the option.
Okay, you are saying that we can somewhere provide a three-way valve kind of a solution.
Correct,
So
correct.
we can provide a control loop over there and provide a three-way valve, so that
Exactly.
according to the temperature.
Yes, exactly. Three-way valve is the best option. This
Sir,
is
but
just
then,
applicable for the heating systems and cooling systems only.
sir, sir, like as you said in heating systems, no, sir, for there, like there may be a possible of pump surging, no, sir, due to the temperature of the fluid in case of hot oil.
Why? No, pump is designed for that particular temperature only. A pump of the hot oil will be designed for that particular temperature only. Hot oil का pump उसका NPSH भी उतना रहेगा.
Okay, sir. Okay, sir.
Like, see, मुझे क्या करना है? Best efficiency point पे चलाना है. That is the motive, right? So my pump is already designed for a good amount of NPSH. It is low NPSH pump. It is already designed for 260 डिग्री सेंटीग्रेड. मैंने उसको पहले से ही डेटा दे दिया. ऐसा नहीं है कि I will be operating, मैंने जब डेटा दिया I will be operating at 50 and now I am operating at 250. No, always hot oil pumps are designed somewhere around 250 से 350 के बीच में. Hot oils are always low vapor pressure.
Sir, I'm having one question. Actually, I'm having confusion between what is pump hydraulics and pump sizing. I don't. I'm very confused in this.
Nearly both is same only. Hydraulics, all calculations of pressure drop and sizing and velocity. Sizing is basically once you are done with the hydraulics, right? Suppose you want to size a pump. We will see one case study. It will be more clear. Just we will see a case study related to design. So I will open one of the Excel sheet. With that, it will be more clear.
Okay, sir.
One of the question. Hello.
Circulation line. I have one doubt about the circulation line.
हाँ बोलिए.
मेरा एक्चुअली डाउट ये था कि जब हम सर्कुलेशन लाइन प्रोवाइड कर देते हैं, so it will be draw a certain flow, na?
Yes, it will draw certain flow rate.
It will draw certain flow, and as the flow increases, my pressure will be reduced. I can say the head will be reduced, pump head will be reduced.
Okay.
So the main purpose, or my main line that I use to transfer the material, the head inside that line will reduce.
So suppose basically what we do is, first of all, when we start the pump, we do the recirculation. Once the flow is established, your pump is not cavitating, you slowly open your line where in the plant or in the process wherever you require the flow rate. Suppose you require whatever flow rate you required. आपने recirculation line पहले, first of all you will full open the recirculation line. Once that is done, you will start diverting your flow rate by opening the plant side valve. अभी आपने प्लांट का भी वाल्व फुल ओपन कर दिया, रिसर्कुलेशन का भी फुल ओपन कर दिया, बट यू आर नॉट गेटिंग सफिशिएंट फ्लो रेट इन द प्लांट, देन यू विल स्टार्ट थ्रोटलिंग द रिसर्कुलेशन लाइन. फिर आप रिसर्कुलेशन को थोड़ा थ्रोटल कर दो तो आपको प्लांट में सफिशिएंट फ्लो मिल जाएगा.
मेरा बोलने का एक्चुअली पर्पस ये है कि जैसे मेरा तो जो फाइनल मेरा प्रोडक्शन है, चलो वो तो कंट्रोल वाल से कंट्रोल हो रहा है, समझो आप, मतलब वो तो मेरा कंट्रोल लूप दिया है, वो प्रोडक्शन जो है कंट्रोल से कंट्रोल हो रहा है. बट मेरा बोलने का मतलब ये है कि गिविंग अ रिसर्कुलेशन लाइन समवेयर इम्पैक्ट द डिजाइन एज वेल. आई थिंक मतलब वो एक्स्ट्रा कॉस्ट ऐड करेगा, मेरे को ओवर साइज पंप डिजाइन करना पड़ेगा. आई थिंक मेरे को लगता है कि रिसर्कुलेशन लाइन के लिए अगर मेरे को हेड की रिक्वायरमेंट ज्यादा है, तो अगर मैं रिसर्कुलेशन लाइन देता हूँ तो मेरे को एक्स्ट्रा हेड के लिए डिजाइन करना पड़ेगा. आई थिंक, एम आई राइट?
So recirculation line extra heads generally whenever you mention, suppose आप कोई भी पंप का और मेंशन करते हो, so that is basically the BEP, right? That is the best efficiency point. आपका जहाँ पे भी पंप कर रहेगा तो वो BEP रहेगा. तो BEP के आगे पीछे you are getting that margin ना. आपको जैसे कि you are saying 30 मीटर हेड, तो आपको 30 नहीं, वो 35 के लिए देगा. The pump is always designed for the end of the curve, right? आप बीईपी पे ऑपरेट करना चाहते हो, इसका मतलब 30 मीटर हेड, मतलब ऐसा नहीं है कि 30 के ऊपर कुछ नहीं मिला. दैट जनरली वेंडर गिव्स यू सम मार्जिन. आप अगर कर्व देखो तो व्हाट विल हैपन व्हेनेवर यू से 30 मीटर हेड, दैट इज द ऑपरेटिंग पॉइंट. उससे आगे भी आपको पूरा कर्व एक्सटेंड होता है. सो दैट इज वेयर यू कैन यूज दैट कर्व. सो नाउ रिसर्कुलेशन लाइन, सपोज इफ यू ऑलवेज, आपका प्लांट में ऐसा है कि ऑलवेज यू विल बी ऑपरेटिंग विद बीईपी, देन नो नीड ऑफ रिसर्कुलेशन लाइन. रिसर्कुलेशन लाइन इज ओनली नीडेड where your flow rate might suddenly throttle. जैसे कि आपको अभी 100% रिक्वायरमेंट से suddenly your plant requirement reduces to 0. आपको प्लांट में फ्लो डालना ही नहीं है. राइट. सो इन दैट केस योर रिसर्कुलेशन लाइन विल बी यूजफुल, क्योंकि पंप अगर आपका ज्यादा टाइम 15-20 मिनट या हाफ एन आवर शट ऑफ में काम किया, then your seal will get damaged if your pump runs on shut off. So recirculation line sole purpose है your pump should never run on shut off, and your
Okay, now I'm getting. Now.
Okay.
Thank you.
मिनिमम सर्कुलेशन लाइन को कंट्रोल कैसे करते हैं?
Minimum circulation line generally you have option उसका. Most of the time minimum circulation line, if your discharge valve का line size है somewhere around 2 to 6 inch, then your recirculation line will be 1 inch, and 10 to 15% or somewhere around 20%, right, 20% of the flow rate maximum should be diverted to the recirculation line. उस हिसाब से उसका line sizing करना है. And you can also provide a orifice, right, flow orifice या restriction orifice also you can provide, so that आपका fixed amount of flow rate goes in the recirculation line. Mostly we never provide orifice. Generally 1 inch का recirculation line is a standard one. 1 inch or up to 6 inch of discharge line, then 1 inch of the recirculation line. 6 inch से 10 inch है अगर आपका pump का discharge line, then your recirculation line will be 40 NB, right. अगर 10 इंच से अबव है, then your recirculation will be 2 inch 3 inch, right. मैक्सिमम 3 इंच से ऊपर आपका recirculation लाइन कभी नहीं होगा.
इसमें कंट्रोल वॉल लगाते हैं या कैसे कंट्रोल करेंगे, मतलब orifice
Orifice is one of the option. See, आपको recirculation का flow control करने की या तो provide orifice or you should provide a manual valve. So manual valve is the easiest option. Most of the companies or organizations give a manual valve only. Orifice is also one of the good option if you want a fixed amount of flow rate going in the recirculation line. अगर आपको for example 10 मीटर क्यूब पर आवर का पंप है और 10% के हिसाब से 1 मीटर क्यूब per hour should go in the recirculation line, then you should provide a orifice for that 1 meter cube per hour of flow rate. Flow orifice design करके you can do that.
Okay.
Sir, in case of manual valves, which valve can we prefer, sir? In case of manual valves, which type of valve can we prefer?
Mostly for a recirculation line and for a lesser flow service, plug valve is the ideal choice. Plug valve or ball valve generally we use. Most of the time with chemical industries we use plug valve or ball valve, and similarly for refineries the gate valve and the globe valve are the standard choices.
Okay, sir.
At lower flow rate, plug valve and ball valve, and at higher flow rates it is gate valve and ball valve.
Sir, I have a doubt related to the recirculation line. So, what is the standard practice to install the minimum circulation line for the pump? Like we have the two pumps, so we need to give the minimum circulation line individually or at the common discharge point to the for the safety of the pump.
So you have two different pumps operating in parallel.
Yeah, we can say, sir, there is the one pump standby, one pump is running. So what is the
common?
standard?
You can give any, if one common recirculation line is enough. If you have same fluids, आपका fluid is same, and if at a time only one pump will be running, then you should give only one recirculation line.
Okay. But some people ask to give the their two circulation line individually. So what
No,
would be the
there is no require. If suppose your fluids are different, suppose one is a sulfuric acid, one is a nitric acid, different fluids are there, then you should give different line. If your pump suction is same, then recirculation line should always be same. If pumps are running in parallel, one running and one standby, then recirculation line, one single recirculation line is also sufficient.
Okay, fine. Fine, sir. Thank you.
Sir, I have a question.
हाँ बोलिए.
सर एक्चुअली सेंट्रीफ्यूगल पंप और जो कैन पंप होते हैं सर, उसमें एफिशिएंसी का डिफरेंस मेनली क्या आता है, जैसे कि हम आगे सेक्शन बनते हैं होते एक्चुअली.
सो आपको क्या लगता है किसमें एफिशिएंसी ज्यादा मिलेगा, सेंट्रीफ्यूगल पंप में या कैंड पंप में?
यस सर मेनली जब हम आगे वाल थ्रोटल करेंगे तो क्या है कि आप बोल रहे थे कि एफिशिएंसी डाउन होते, तो एक्चुअली दोनों में से ज्यादा डिक्रीज किस में होगी, सेंट्रीफ्यूगल में होगी या कैंड पंप में एक्चुअली में सर होगी? और मैक्सिमम एफिशिएंसी
is a type of centrifugal pump only.
Yes sir.
कैन पंप मतलब क्या है? इट इज अ सेंट्रिफ्यूगल पंप ओनली ना?
Yes, sir. Yes, sir.
It's a positive displacement pump, sir. It comes under rotary pump, sir.
No. Canned
Cam
pump is the centrifugal pump. Canned pump is, you are saying about the canned pump, that is a magnetic drive ना? Mag drive pump का बात
Yes,
कर
sir.
रहे हैं ना?
Yes, sir. Magnetic drive. Yes, sir. Yes, sir. Magnetic
Magnetic
drive.
drive pump, canned pump बोलते हैं उसको. That is nothing but a centrifugal pump. So basically efficiency is comparatively little bit less. थोड़ा ही कम रहेगा centrifugal pump से. The reason is because आपका क्या होता है, आप उसका पहले इलेक्ट्रिकल एनर्जी मोटर में आती है, मोटर से थोड़ा लॉस होके शाफ्ट से कपलिंग लॉसेस होते हैं, कपलिंग लॉसेस से पंप में जाता है और पंप से फिर फ्लूइड में जाता है. तो कैंड पंप में कैसा होता है, इलेक्ट्रिकल एनर्जी मोटर में आएगा, मोटर से फिर अंदर देयर इज अ इनबिल्ट कपलिंग. सीललेस पंप मतलब क्या है, सील बाहर से नहीं दिखेगा, अंदर ही उसका ट्रांसमिशन हो रहा है. द पावर ट्रांसमिशन हैपेंस इनसाइड द पंप थ्रू अ मैग्नेटिक ड्राइव. आपका जैसे मोटर रोटेट करता है तो अंदर कॉइल्स रोटेट करती है. सो आपका जो पंप है ना, पंप इज अ मैग्नेटिक ड्रिवन. तो पंप के अंदर भी कॉइल्स है, मोटर में भी कॉइल्स है. So whenever your motor rotates, what will happen, because of induction, because of the magnetic field that is created, your pump will start rotating. So that loss is transmission through a coupling or transmission through a magnetic field. So magnetic field में comparatively losses ज्यादा है. That's why for a similar application, can pump में 2 to 3% efficiency loss रहेगा. Is it clear?
Yes, yes, sir. Is it clear, sir?
And for information, canned pumps are centrifugal pumps. They are not PD pumps.
Okay, sir. Okay, sir.
Okay. So is my screen visible?
Yes, sir. Yes, sir.
Okay.
Please mute. Somebody is having background voice.
Yes, just a minute. I will mute them. Visible है ना? Read. You can read it, right?
Yes, yes.
Okay. So this is one standard sheet that I have prepared. Right. So here you can also label everything related to the pump, the organization, everything. Right. So first of all, we will have a duty case. So duty is to transfer trichloride, that is phosphorus trichloride, from a tank to the tanker. Right. So whatever is the material. So blue is basically the input and green is the calculated value. So I will quickly brief how basically sizing is done and what are the formulas that are used. So basically you have a pumping temperature. So whatever your temperature is there, so that is required. Like my basic intention is whatever values are asked by designing, जो भी values हम मांगते हैं designing के time पे, so what is the significance, why those values are required. So that's why I will just explain why these values are required and how they are used. So when we say the pumping temperature of that particular fluid, there is the phosphorus trichloride. So POCl3 का 20 डिग्री टेम्परेचर पे कितना वेपर प्रेशर होगा. From the Antoine sequence equation you can find out the vapor pressure, or from the literature you can find out the vapor pressure. So that vapor pressure will be used to calculate the NPSH, right? So now my design flow rate is 20%, right? So what will be the normal flow rate? It will be somewhere around 11. So I have taken 5% as the margin. इसको sorry, okay, normal flow rate will be somewhere around, design is 20, so normally somewhere around 11 meter cube is the normal flow rate, maximum flow rate is 20, right? That I have selected. So normal is the operating point, maximum is the 20. Density is somewhere around 1585 is the density of the POCl3. Just a minute. Yes, 1585 is the density, right? Kg per meter cube. Viscosity is again I need to just check. Viscosity is 5 centipoise, right? So viscosity is 5 centipoise. Your vessel suction pressure. So your vessel suction pressure is 1 bar absolute. So it means it is atmospheric vessel. It is open to atmosphere because atmospheric pressure is 1 bar absolute. So 1 bar is equal to nearly 1 atmosphere. So it is open vessel. Suppose your discharge pressure I am putting 2, right? So my discharge pressure is 2. What does it mean? The pressure of the discharge vessel is 1 kg per centimeter square gauge, right? What is the equipment loss? So wherever my flow is passing through the heat exchanger or through the any equipment, so there is no loss. It is passing directly. So there is no loss because of the control valve or due to equipment, right? So what is my material? That is CSPTFE. What is the suction line size? That is 3 inch. There is 71.72. Discharge line size is 1.5 inch. That is 33.27 is the nominal size, right? So first of all, these are the values that we generally ask for. So now what we will calculate? So once we have this data, right? Sorry, this discharge line will be 33.27. No? Okay, so I will just match this CSPTFE 71.72. Okay, 71.72. Okay, so now what will happen? First of all, we will calculate the fluid velocity in the suction, right? So basically what we can do is, you have the equation flow rate, volumetric flow rate, that is meter cube per hour. It is equal to velocity multiplied by the area, right? Area of the pipeline. So what we can do is, we can calculate the velocity by volumetric flow rate divided by the area of the pipeline, because we have the 3 inch of the suction line. 71.72 is the suction line size, right? So I'm getting fluid velocity from that. So you can see flow rate, here it is 15, it will be 20. So you can see how from 15 to 20, if I increase the flow rate, my velocity will increase. So my velocity increased, right? You can see that. So if I calculate the suction side velocity, right? So if I increase the suction side velocity, what will happen? At higher velocity, your Reynolds number will increase, your friction factor will increase. So you can see over here, if I increase the suction line size, right? So you can see over here, what is the change over here? Frictional losses में क्या change होता है? You can just see suction line was 3 inch. If I increase to 2 inch, then it is reducing. Sorry. It is basically you are getting from. Okay. So you can see, if I am reducing the suction line size, then what will happen? Your velocity will increase, right? This is the velocity. You just note it down. Okay, it is not linked with this. So velocity में कौन सा formula है? Okay, I'm using this particular formula. So suppose 71.72 is the nominal size, right? If I reduce to 50, then what will happen? You can see my velocity increase 2.8, my suction side pressure drop and frictional loss increase. अगर मैं उसको 50 से 40 करता हूँ, see this is increasing because at higher velocity, at higher Reynolds number, your losses are higher, right? That's why your suction side pressure drop increases. So we should always design in such a way, as a thumb rule, it is a standard to keep your velocity somewhere around less than 1.5 meter per second in the suction, and in the discharge it should be somewhere around 2 to 3 meter per second, right? So in that particular scenario, your pump will be working fine. Certain in certain fluids, like suppose class A solvents like benzene, right? So it is always recommended to keep your velocity, suction side velocity, less than 1, and discharge side velocity 1.5 to 2, because at very high velocity there is very high possibility that it might catch some static charge, right? Similarly in CS2, carbon disulfide, it is always recommended to keep your velocities, suction side as well as the discharge side velocities, very less, right? So with this type of fluids you have to take care. So for our POCl3, suction side velocity is okay with respect to 3 inch line size. So our pressure drop, right, it is sufficient. Now again, for the suction side, what I will do, what are the different types of valves, different types of line and basically connections and fittings. So based on that, I will calculate what is the head, right? So suppose मैंने जैसे बताया था, by throttling the valve, what you are doing is that throttling of the valve is resulting in some head loss because in some frictional losses. Similarly, different valve fittings will give me different head losses, right? So similarly, plug valve, 90-degree elbow, standard T. So it will give me different head losses in terms of meters. So what is that summation? It is somewhere around, based on the numbers of fittings, it is giving me 17.82 equivalent length of pipe fitting का head loss मिल रहा है. So what is equivalent length of pipe? So suppose if there is a valve, right? There is a globe valve, suppose, and the equivalent length of pipeline for that globe valve is suppose 10 meters. So what is 10 meters? So particularly that globe valve will give me pressure drop, right? It will give me the pressure drop same as that of a 10 meter of pipeline size of that particular suction line. अगर आपके suction line में एक globe valve है और suction line का size 3 इंच है, so that globe valve will give me equal amount of pressure drop which I will get from 3-inch line having 10 meter of length, right? Every line with respect to diameter and height, diameter and length will give me some pressure drop. So equivalent length of pipeline मतलब क्या है? That is the length of the pipeline with the diameter of with a particular diameter which will give me pressure drop equal to that number of valve fittings. तो मेरे section में जो valve fittings मुझे कितना pressure drop दे रहे हैं? 17.92. And what is the length of my suction line का length कितना है? That is 8 meters. So total my line length is 25 meters. Now 25 meter of the line length based on the fanning friction factor, I am getting some amount of the length, and based on that length I will get the head losses in the suction, right? So my suction head is somewhere around 1 meters. Is it clear? Yes or no?
Sir, please repeat equivalent length of pipe. Please.
So suppose equivalent length मतलब क्या है? It is nothing but a conversion only, right? So suppose 1 rupees is equal to $75. That is nothing but a $1 is equal to 75 rupees. So it is nothing but a conversion. So suppose I have a globe valve, right? I have a globe valve. So what will happen? That globe valve is providing me pressure drop और उसका equivalent length है 10 meters. So there is on one side there is a globe valve and on other side there is a 3-inch pipeline with 10 meter of length. So globe valve में जो pressure drop होगा, that pressure drop will be equal to a pressure drop that is created in a 3-inch diameter and 10 meter of length of pipe. So उसको हमने क्या किया, globe valve का जो pressure drop था उसको equivalent length of pipeline में convert किया. Is it clear? Yes or no?
Yes sir, clear. Yes.
आपको कोई एक वाल्व का डायरेक्ट प्रेशर ड्रॉप मालूम नहीं है तो आप क्या करते हैं उसको, यू कैन कैलकुलेट द प्रेशर ड्रॉप थ्रू अ पाइपलाइन, राइट? यू हैव द इक्वेशन डेल्टा पी इज इक्वल टू 8FL/D रो V square by 2G करके इक्वेशन है, राइट? फॉर अ पर्टिकुलर लेंथ फॉर पर्टिकुलर डायमीटर. सो आपने क्या किया, अलग अलग वाल्व फिटिंग्स का कुछ प्रेशर ड्रॉप है विद रिस्पेक्ट टू इक्विवेलेंट लेंथ. अभी सक्शन में मेरे वाल्व फिटिंग्स है तो उसका डायमीटर कितना होगा, सक्शन लाइन का पाइपलाइन डायमीटर जितना है, दैट इज द 3 इंच, राइट? So suppose I have this amount of valve fittings, तो जिनका हेड को मैंने कन्वर्ट किया 4 मीटर 9 मीटर, तो सबका हेड कितना आ रहा है, all the valve fittings head is somewhere around 17.82. तो 17.82 मीटर लंबा लाइन है और 3 इंच इज द डायमीटर. तो उतने लाइन में विदाउट एनी वाल्व फिटिंग, उतने स्ट्रेट लाइन में अगर कुछ प्रेशर ड्रॉप होगा तो प्रेशर ड्रॉप किसके इक्विवेलेंट होगा, इट विल बी इक्विवेलेंट टू these line fittings. Is it clear now?
Yes.
ओके. सो मैंने क्या किया, सक्शन साइड का प्रेशर ड्रॉप फाइंड किया, राइट? सिमिलरली व्हाट आई विल डू इज आई नीड टू फाइंड द डिस्चार्ज साइज का प्रेशर ड्रॉप. वंस आई विल गेट द सक्शन हेड, वंस आई विल गेट द सक्शन प्रेशर और डिस्चार्ज प्रेशर, मुझे क्या करना है, बस पंप का कितना हेड है वो ही फाइंड करना है. फ्लो रेट तो मुझे पता है 20 मीटर क्यूब. सिमिलरली लेट अस फाइंड व्हाट इज द सक्शन डिस्चार्ज साइड. तो डिस्चार्ज साइड का वेलोसिटी तो बहुत ज्यादा आ रहा है, राइट? सो व्हाट आई कैन डू इज आई हैव टू रिड्यूस. तो कैन यू टेल मी व्हाट इज द इकोनॉमिकल पाइप डायमीटर, कोई बता सकता है व्हाट इज इकोनॉमिकल पाइप डायमीटर? यस. Generally what happens, if you select a lower diameter then it is very cheaper. आप 1 इंच का पाइपलाइन लो और 4 इंच का पाइपलाइन लो तो 1 इंच का पाइपलाइन चीपर होगा. So what will happen, your initial cost is lesser, but with 1 inch pipeline, if your velocity is higher, then what will happen, wear and tear is higher, and at higher wear and tear, higher velocity, योर मेंटेनेंस कॉस्ट विल बी हाई। आपको बार बार लीकेज अटेंड करना है, वेल्डिंग करना है, गैस्केट चेंज करना है, फ्लैंज जॉइंट लीक हो रहे हैं। सो इकोनॉमिकल पाइप डायमीटर इज अ डायमीटर एट विच योर प्राइस इज ऑप्टिमम। आपका 10 साल में ऐसा पाइपलाइन, अगर सपोज आई एम यूजिंग, यहाँ पे क्या हो रहा है, यू कैन सी माय डिस्चार्ज पाइपलाइन वेलोसिटी इज 6.3 विच इज वेरी हाई। अगर मैं डिस्चार्ज में कितना लिया है मैंने, आई हैव यूज अ 1.5 इंच, राइट, उसकी जगह पे मैं 2 इंच ले लूंगा। सो 2 इंच विल बी समवेयर अराउंड 48.52, इट विल बी समवेयर अराउंड और 47 जैसा कुछ उसका 47.5 लेता है, दैट विल बी द एनबी, राइट। सो उतना अगर मैं लेता हूँ, देन सी माय डिस्चार्ज वेलोसिटी रिड्यूस्ड टू 3.18, राइट। सो बेसिकली इकोनॉमिकल पाइप डायमीटर मतलब क्या होता है, diameter at which your velocity is optimized in such a way that your fixed cost will also be fixed cost along with the operating cost will be at the optimized condition। अगर मैं ज्यादा वेलोसिटी सिलेक्ट करूंगा कम डायमीटर वाला, तो मेरा इनिशियल कॉस्ट तो कम है, बट माय ऑपरेटिंग कॉस्ट विल बी वेरी हाई, राइट। सो based on the discharge velocity, based on the Reynolds number, I have calculated the friction factor, and सिमिलरली डिस्चार्ज वाल के फिटिंग्स के इक्विवेलेंट लेंथ से आई विल कैलकुलेट द डिस्चार्ज हेड। सो दीज बोथ हेड फ्रिक्शन लॉसेस इन द सक्शन एंड डिस्चार्ज, राइट। सक्शन में है 1 मीटर और डिस्चार्ज में कितना है 8.2। सो दिस इज द अमाउंट ऑफ फ्रिक्शन लॉसेस आई हैव टू ओवरकम बिकॉज ऑफ दिस लाइन फिटिंग इन डिस्चार्ज एज वेल एज द 14 मीटर ऑफ लेंथ ऑफ द डिस्चार्ज पाइपलाइन। तो मुझे कितना करना है 8.2 मीटर उसका ओवरकम करना है फ्रिक्शनल लॉसेस। नाउ वी विल सी कि what is the total amount of head, what is the dynamic head I need to overcome, right। so यहाँ पे हमने ले लिया सक्शन साइड एज वेल एज द डिस्चार्ज साइड। तो सक्शन साइड में वेसल का प्रेशर कितना है, इट इज बेसिकली 6.435 meters। so this is the meter F15 by E13, right। so it is basically okay, discharge में I will put 2 kg 2 bar atmosphere, right। so basically यू कैन सी सक्शन में आपका वेसल प्रेशर कितना है, इट इज 1 एटमॉस्फेयर एब्सोल्यूट, राइट। इट मींस इट इज एटमॉस्फेरिक प्रेशर, whereas in discharge it is 2 atmospheric bar, right। so it is 1 kg gauge। so यहाँ पे आपका डिस्चार्ज में कितना मीटर आ रहा है 12.87। so यहाँ पे जो मीटर है इट इज विथ रिस्पेक्ट टू मीटर ऑफ POCl3 बिकॉज उसका डेंसिटी कितना है 12.85, राइट। सो दिस इज द मीटर ऑफ लिक्विड कॉलम। तो यहाँ पे आपको सक्शन में 6.4 मिला। what is the height of liquid level above the pump, यानी कि टैंक में 1 मीटर हाइट है। so what will happen 6, अभी हम कैलकुलेट करेंगे NPSH भी, राइट। so आपको पहले तो एटमॉस्फेरिक प्रेशर है उसके कारण 6.43 मीटर्स है प्लस 1 मीटर बिकॉज ऑफ द लिक्विड लेवल, तो टोटल 6.4 प्लस 1 दैट इज 7.4 माइनस 1.097। क्यों माइनस, हाउ डिड दिस केम, इट इज बिकॉज ऑफ द frictional losses in pipeline, right। so it is because of the frictional losses in the pipeline। तो आपका ये लॉस जो हो रहा है ना, right, it is because of this particular value, right। आपका जो फ्लूइड वेलोसिटी था वो और ये उसके हिसाब से आपका फ्रिक्शनल लॉसेस जो हो रहा है वो, राइट। सो आफ्टर दैट कंट्रोवाल, तो कोई कंट्रोवाल नहीं है, कोई ओरिफिस नहीं है, कोई इक्विपमेंट नहीं है, दैट्स व्हाई ऑल दिस लॉसेस आर जीरो। नाउ व्हाट इज योर टोटल सक्शन हेड, it is somewhere around 6.338, that is the suction head। similarly discharge में आपको जो मिल रहा है, what is the height of the liquid in the discharge tank, what is the frictional, so आपने देख सकते हो 8.751 is the head loss in the discharge, right। so ये यहाँ से आया velocity head as well as the friction head, so that is the frictional losses। orifice, suppose you have put a orifice in the discharge, right, here I have mentioned I have put a orifice, right। so IS17 or F12, so on the top, right। so here in the discharge I have put a orifice of 25 mm, right, or in order to control the flow rate, so that's why because of the orifice I am having some pressure drop, so this is very high amount of pressure drop। तो हम orifice का size change भी कर सकते हैं, it's 25 mm right now। so based on the flow rate, suppose I do it, suppose मैं उसको 40 mm कर देता हूँ, 40 mm का ओरिफिस कर देता हूँ, and my that pressure drop will reduce. जो पहले 12 था वो भी 14 था या 12 था, it reduced to 2 meters, right? So that is because of the orifice. Orifice nothing but the restriction in the flow rate, right? So उसके कारण भी कुछ प्रेशर ड्रॉप हो रहा है. So because of that my total discharge का head loss कितना है या discharge में कितना प्रेशर मुझे चाहिए, that is 30. So now discharge has 30.298 or 30.30 and suction has 6.338. So what is the total differential head? That is 30 minus 6.3. So that is 23.96. So अगर मेरे पास मुझे रिक्वायरमेंट है 30 मीटर हेड का और मेरे सक्शन में ऑलरेडी 6 मीटर हेड है, अवेलेबल इज 6 मीटर बिकॉज ऑफ द ऑल द थिंग्स, एटमॉस्फेरिक प्रेशर, लिक्विड लेवल, फ्रिक्शनल लॉसेस. तो मेरे पास नेट इज 6 अवेलेबल इन द सक्शन एंड आई वांट 30 इन द डिस्चार्ज. सो मेरा पंप कितना बूस्टअप करना है, दैट इज 24, दैट इज 23.96. यानी कि अगर मेरे पास 100 रुपए है और मुझे 150 रुपए करना है तो मुझे कितने का डेफिसिट है, दैट इज 50 रुपीज डेफिसिट. सिमिलरली यू वांट 30 एंड यू ऑलरेडी हैव 6, सो योर पंप इज बेसिकली डिजाइन फॉर 23.96, राइट? इसमें आप 10 to 20% मार्जिन भी ले सकते हैं. यू कैन सिलेक्ट 28 और 30 मीटर हेड का भी पंप ले सकते हो, राइट? वी विल सी दैट मार्जिन्स. So now talking about the NPSH.
One thing, how this orifice pressure drop calculated?
There is one equation to calculate the pressure drop through orifice.
What is that? Can you show us?
Actually, it is not available right now. I need to go with पूरा book open करना पड़ेगा उधर से.
Sir, is the pressure is equal to the pressure drop formula will be equal to the same as like in the orifice meter, sir?
No, it will be little bit different.
The equation will be different.
Ultimately, it is same only. Like the fundamental is same only, but it will be little bit different.
Okay.
Okay. Just a minute. I will see. It is basically based on the orifice discharge coefficient, delta P, density, and ratio of the inner diameter and the pipeline diameter. Right? Beta is there. D by D ratio. So
अगर इसका सक्शन हेड कम कर दिया जाए तो क्या डिस्चार्ज प्रेशर कम हो जाएगा? डिस्चार्ज हेड कम हो जाएगा?
Yes, definitely. Suppose आप सक्शन हेड जो 6 है ना, आप उसको 0 कर दो. So what will happen?
5 कर देते हैं, 5 कर देते हैं.
Okay.
तो डिस्चार्ज हेड कम हो जाएगा.
सी दो चीज है. जब आप पंप डिजाइन की बात करते हो, सो डिजाइन में क्या है, यू वांट डिस्चार्ज में कितना प्रेशर चाहिए आपको, 30 मीटर चाहिए, सक्शन में 6 है, तो क्या होगा, आपको 23 मीटर पंप बूस्ट करेगा. सिमिलरली अभी मैं उसको सक्शन में 3 कर देता हूँ या 2 कर दिया, लेकिन मुझे डिस्चार्ज में तो 30 चाहिए ही, तो मेरा पंप का बढ़ रहा है. सी अगर मैं 0 कर देता हूँ पंप का सक्शन प्रेशर, तो मेरा डिस्चार्ज प्रेशर विल बी सेम एज दैट ऑफ पंप हेड. लेकिन अब ऑपरेशन, सी पंप में एक ही चीज है, मोस्ट ऑफ द पीपल गेट कंफ्यूज बिटवीन द ऑपरेशन ऑफ अ पंप एंड डिजाइन ऑफ अ पंप. अगर मैं ये पंप डिजाइन करता हूँ और मैंने 24 मीटर का हेड का पंप सिलेक्ट किया, उसको मैं प्लांट में लगाता हूँ और उसका अगर मैं प्रेशर ये कम कर दूंगा, राइट, इफ आई सक्शन प्रेशर जो है उससे भी कम कर दूंगा, देन व्हाट विल हैपन, डिस्चार्ज प्रेशर उसको कम हो जाएगा, डिस्चार्ज प्रेशर विल बी लेसर. अगर आप सक्शन प्रेशर कम करोगे तो डिस्चार्ज प्रेशर कम होगा. क्यों कम होगा? बिकॉज सक्शन प्रेशर कम हुआ, लेकिन पंप आपका किसके लिए डिजाइन है, डिफरेंशियल हेड के लिए. आपका पंप है 24 मीटर का, लेकिन विथ रिस्पेक्ट टू 6 मीटर ऑफ द हेड इन द सक्शन, अगर आप पंप के सक्शन 0 मीटर हेड कर दोगे,
तो अगर हम इसका 10
अगर आप पंप का
मीटर
प्रेशर 6 कर दो, सक्शन का प्रेशर 6 मीटर कर दोगे,
अगर
सक्शन कर देंगे तो 34 मीटर हेड देगा, 34 मीटर हेड देगा,
34 मीटर देगा. ओके. वही चीज मैंने पहले पूछा था ना कि अगर सक्शन प्रेशर हम बढ़ा देते हैं तो हेड बढ़ जाएगा हमारा, तो आपने ना बोला था पहले.
सी हेड बढ़ जाएगा मतलब वही बोल रहा हूँ, डोंट कंफ्यूज बिटवीन द हेड ऑफ द पंप एंड प्रेशर ऑफ द सिस्टम. हेड मतलब क्या है, 24 मीटर हेड ही रहा है, पंप का हेड चेंज नहीं हो रहा है, आपका प्रेशर बढ़ा है. आपका प्रेशर, मैंने क्या बोला था, सी आप पंप का सक्शन प्रेशर 10 कर दो तो डिस्चार्ज प्रेशर विल बी 34. तो डिस्चार्ज प्रेशर इज 34. हेड तो अभी भी 24 ही है, हेड नहीं बढ़ा है, आपका प्रेशर बढ़ा है, हेड नहीं बढ़ा है.
यस. ओके.
पहले भी मैंने यही बताया था. यस और नो, क्लियर है ना सबको? कोई डाउट तो नहीं है?
ओके ओके,
एक बार
पहले आई थिंक मैंने पहले भी शायद यही बताया था, आपको थोड़ा कंफ्यूजन हुआ है। यस और नो, बाकी सबको तो
ओके
क्लियर है ना?
ओके ओके
यस यस ओके सर।
Yes, sir.
Okay.
Okay.
So what will happen? This suction pressure, you want to calculate the MPSS.
there is a one query.
हाँ बोलिए। ओके
सर हम पहले बात हुआ था कि करके हम अब हेड चेंज नहीं हो रहा है एक्चुअली, है ना?
हेड विल नेवर चेंज, हेड इज अ प्रॉपर्टी ऑफ अ पंप, इट विल नेवर
मतलब
चेंज।
पंप का जो हेड है वो एक किसका डिजाइन, या इट्स अ डिजाइन
हेड ऑफ अ
कैरेक्टरिस्टिक, और
हेड
वी
ऑफ अ
कांट
पंप विल
चेंज द
नेवर चेंज।
पंप हेड without playing pump internals. Yeah, so without changing the pump internals or the RPM, I can change the head.
Yes, without changing the impeller diameter,
Sir,
your
जब
pump
हम
will never change. Pump will only
या
head of the pump will only change if you
या
change the impeller diameter. सपोज आप जब बता रहे ना, अब मैंने आपको
जब हमने
सिस्टम
वाल
कर्व,
थ्रोटल किया था, डिस्चार्ज वाल थ्रोटल,
यस मैंने जो आपको सिस्टम कर्व दिखाया था जहाँ पे कुछ स्टैटिक हेड था और कुछ फ्रिक्शनल लॉस था, तो वहां पे क्या कर रहे हैं आप, स्टैटिक हेड बढ़ा देंगे तो दैट्स व्हाई योर प्रेशर इज इंक्रीजिंग। आपका पंप का जो डिस्चार्ज प्रेशर है दैट इज प्रेशर, दैट इज नॉट द पंप हेड। उसको आप डिस्चार्ज हेड भले बोलते हो लेकिन उसको डिस्चार्ज प्रेशर बोलना है। दैट्स व्हाई व्हाट आई सेड, आप पंप का जो हेड रहता है उसको हमेशा हेड क्यों बोलते हो? वेंडर आपको हमेशा बोलेगा मेरा हेड 30 मीटर है पंप का, आप कभी ये नहीं बोलोगे कि मेरे पंप का डिस्चार्ज प्रेशर है 3 kg या पंप का डिस्चार्ज प्रेशर है 30 मीटर्स। हेड इज ऑलवेज कांस्टेंट, हेड इज द प्रॉपर्टी ऑफ द पंप, इट विल ऑलवेज रिमेन कांस्टेंट। इज इट क्लियर?
One
Okay.
question.
हाँ
Vendor
बोलिए।
normally provides for curve for water, right?
ओके, पर
He do not check
मैं
on
चाह रहा
our
हूँ,
fluid.
मेरा क्वेश्चन ये है।
One
He also
question
give
is
for
that
the fluid, आप उसको फ्लूइड के लिए अगर फ्लूइड का प्रॉपर्टीज दिया है, he will also give with respect to fluid, MLC बोलेंगे,
he will
मीटर ऑफ
give
दैट
with
लिक्विड
respect to
कॉलम।
fluid without having that fluid, right?
हाँ, आप वो फ्लूइड के
Example,
लिए भी,
you are giving POCl4, but vendor is not having POCl4, but he will give the pump. So we have to, based on density, we have to provide data or what?
yes, based on density.
Only because pump is designed for water only. They give for water, but we
Agree.
will
So
change the service accordingly, right?
okay, so that is very good question. So I will answer that. Mostly क्या होता है जब आपने बोला कि उसके पास POCl3 नहीं है, agreed. So when it comes to toxic studies, उसका प्रोसेस सेफ्टी पॉइंट ऑफ व्यू, तो उसमें सीललेस लगाना है या डबल सील चाहिए, दैट इज आवर रिक्वायरमेंट, हम उसको बोलेंगे। लेकिन वो
No,
क्या
I am
करेगा,
only
जैसे कि
asking characteristic of, yeah, only
जस्ट लेट
characteristic.
मी आंसर, मैं आपको वही बता रहा हूँ। जब आप उसको POCl3 बोला, आई एग्री उसके पास POCl3 नहीं है, सो मोस्ट ऑफ द टाइम व्हाट ही डज इज, जनरली उसके पास कोई अनदर सॉल्वेंट ही हैज, राइट, हाई डेंसिटी वाला सॉल्वेंट रहेगा उसके पास, ही मिक्सेस इट विद द वाटर, और उसके पास कुछ सॉलिड्स रहते हैं, एक्चुअली आई डोंट नो बट देयर इज सम पॉलीमरिक मटेरियल, he adds along with the water and increases the density of the water, conducts the trial at that particular density, right? Suppose it is a brine, that is a basically it is a brine, suppose MEG brine is there. So when we mix it with respect to water, then its density keeps on changing. So because of that addition, he will make a solution in such a way that the density of that particular material will be 1.585. So in that respect, he will conduct the trial, he will get the pump curve. प्रॉपर्टीज विथ रिस्पेक्ट टू POCl3, वो टॉक्सिक है तो सील लेना, उसका जो भी इंटरनल्स है विथ रिस्पेक्ट टू MOC है, मेटालिक और पॉलीमरिक, CSPTFE और वॉट एवर इट इज, इट विल बी बेस्ड ऑन POCl3। लेकिन जो हेड फ्लोरेट कर्व होगा वो दूसरी डेंसिटी के लिए भी वो जनरेट कर सकता है। और अदर ऑप्शन इज, आप उसको वाटर के लिए, जब हम वी डू दिस ट्रायल्स, वेंडर उसके एंड पे वर्कशॉप में जब ट्रायल करता है विद रिस्पेक्ट टू वाटर, तो उसमें ऐसा भी ऑप्शन रहता है उसके सॉफ्टवेयर में कि एंटर द एक्चुअल डेंसिटी, जहां पे हम उसको एक्चुअल डेंसिटी एंटर किया तो उस हिसाब से कर्व बनेगा, राइट? वॉट एवर द कर्व्स आर प्रोवाइडेड बाय द वेंडर, दे आर ऑल जनरेटेड इन द कंप्यूटर्स। क्लियर है?
So they will provide with our density directly, not we have to change anything, right? Vendor is giving a correct
You will
curve,
mention
not with
उसके सिस्टम उसके एंड पे कैसा सिस्टम है. इफ इट इज अ वेरी गुड नोन वेंडर है तो वो हम उसको बोलेंगे उसमें देगा. हम उसको बोलेंगे मुझे मीटर ऑफ माय पर्टिकुलर लिक्विड के इसमें दो तो उसको उसमें देगा. अगर आप बोलो वाटर के इसमें दो तो आपको वाटर के उसमें भी देगा. जनरली इट इज ऑलवेज प्रेफरेबल टू गेट the head flow rate curve in our liquid, our service fluid only. In both the respect he can give.
Okay.
Yes.
Hello.
हाँ बोलिए.
So my doubt was actually the pump side is somewhere related to the discharge line size as well or not? It is independent from that.
Pump sizing will totally depend on the discharge line. क्योंकि अगर आपका discharge line is lesser, what does that mean? Your flow rate, see your requirement for a plant. Suppose 10 meter cube per hour is the flow rate you want in the plant. But if your discharge line is very very less, suppose it is 15 NB, there is half inch, then what will happen? Your velocity head is higher, your frictional loss is higher.
Yeah.
So what will happen? Your discharge, your pump head, differential head will be higher for that case. You will require 50 meter of head to pump that 10 meter cube of flow rate. Suppose if you increase the line size from 15 NB to 25 meter, then you will require comparatively lesser head to flow that to pump that 10 meter cube of flow rate. Clear?
So I'm actually saying that in the previous example, while we are throttling the valve, the pump head was changing. So the solution of head or kind of a head, the head, the head is
Your voice is breaking. It is
intrinsic.
breaking. I'm not able to listen. If possible, can you please write it down on the
your
chat?
voice is fully breaking out.
If you are traveling, then please you can write on the chat. I will answer your question.
No, I'm not traveling. I'm not traveling. Now I'm audible or not?
Yes, you
Is
are
it clear
better.
right now?
Still, your voice is breaking.
I'm saying that the earlier example, we have seen that while we have throttled the valve or we have manipulated the valve opening in the discharge size, discharge line, so the pump head was changing. Am I right?
Correct. Yes, yes.
Yeah. So I'm saying that the solution, the problem of the pump head, if I'm not getting the head, or I'm getting the extra head, can be solved, or the BEP problem can be solved by changing the discharge line size.
Yes, it can be solved by changing the discharge line size. But what will happen in that case? If you change the discharge line size, suppose in that example, what was happening? Initially, my flow rate was 500 and I shifted to 300, right? So what was happening? My pump curve shifted on the left hand side, and because of that, head increased, right? So what you can do is for the same flow rate, if you want lesser head or you want to change to the BEP, you can change the discharge line size, you can increase the line size. So what will happen in that case? Flow rate will be 300, but your head will be lesser. You will definitely move to the BEP. But suppose it is easier to change a pump rather than changing the entire discharge line size. You are technically correct. If you increase the line size, your flow rate is 300 only, but your head will reduce. You will definitely come towards the BEP. That is correct.
Yeah. Actually, so I can change, but I'm saying that if my circuit is downstream circuit is not that big much, so
You can
to
change the
maintain,
discharge line. Correct.
yeah, so after changing that I can reduce the discharge line. So okay.
Yes, that is correct.
Yeah, okay. And the one doubt is that the pump head, that you're saying that the pump head is not changing, it is the intrinsic quality of the pump design as well.
Yes,
So,
yes.
but while I'm changing the discharge line size, the pump head is changing, na?
It is
Am
not
I
the
correct?
pump head. That is the system curve I'm saying. That is not the pump head. It is a system curve.
Okay. Okay. Okay.
Okay.
Actually, your discharge line is You're saying that the pump discharge gauge is actually showing the system pressure. It's showing the system. Circuit.
Rahul, your voice is very poor. I think we should not waste time on that. If you want, you can write it down on the chat, or I will answer your query after the completion, because your voice is not properly coming.
Okay.
Any other question from anyone else? Okay. Yes, Dhananjay, you have any question? Okay. So basically what we can do is, once you have all the data, you can calculate the NPSH. So NPSH may there are variables. So what happens, first of all, NPSH, when we talk about the suction tank, right? So the head pressure of the suction tank is positive. The liquid level inside the tank, it is also positive. So it will contribute towards the NPSH. The only losses are losses because of frictional losses and losses because of the vapor pressure, right? So 6.34 is the summation of the suction tank pressure as well as the summation of suction tank pressure, liquid level, that is the static head in the suction tank, minus the frictional losses, right? If we substitute, if we subtract the vapor pressure from this pressure, then we'll get the NPSH. So basically, what is, how to calculate the NPSH? Suction tank pressure, it is contributing with the plus sign, and liquid level inside the tank, that is also contributing with the plus sign. These are two are the positive factors which will boost up the NPSH. What will reduce the NPSH? That is the frictional losses, that will be minus, and the vapor losses because of the vapor pressure. So because of that, your NPSH will reduce. So that is your NPSH required, available, right? So vendor will give you NPSH required, which will be 5 or 4, so that always your available NPSH will be more than the required NPSH. आपने ये जो कैलकुलेट किया, व्हाट इज दिस इज बेसिकली एनपीएसएच अवेलेबल, राइट? दिस इज एनपीएसएच अवेलेबल. So always your NPSH should be more than this. So vendor will give you NPSH which will be lesser than this, required will be less than this, right? Similarly, you calculate the power. You suppose whatever the efficiency is there, based on the 60% efficiency, you can calculate the power based on the flow rate, differential head, that is 23.96, and the density. So you will get 3.44 kilowatt of the power that has to be supplied to the pump. What should be the size of the motor? It will be 3.44 divided by 0.85. Generally, all the motors comes either 85% efficiency or 90% efficiency. So somewhere around 4 kilowatt motor you need for this particular purpose, right? So generally, how to calculate the discharge head? It is nothing but the losses plus what is the source tank level, source pressure. Based on that, you will size the discharge head, right? So that is all about the pump sizing. Similarly, you can also get the pump curve, right? At different flow rates, you will get the pump curve. So vendor will give you the pump curve on that basis. So this is the system curve, right? How your flow rate changes with respect to your head, right? So that's about the sizing of a pump. Hydraulics. So hydraulics is basically everything related to suction and discharge line pipe sizing and pressure drop calculations. And sizing is about finalizing the head of the pump, finalizing the impeller diameter, and select the best operating point. Okay. So with this, we have completed the session. If you have any queries, then you can ask now.
Okay, sir, I have one query. Is there any relation between the suction pressure available at the pump suction and the delta P available in the discharge side of the control valve?
On the discharge side of the control valve, that is a delta P, pressure drop across the control valve, and what did you say?
Suction and the pressure available at the suction.
Pressure available in the suction of the pump and the
Yeah,
delta P
yeah.
across the control. As
Yes,
such,
yes.
there is no difference. There is no direct connection. But if you
Yeah.
say because of the lower suction pressure, your pump is cavitating, it is not developing sufficient discharge pressure. Because of insufficient discharge pressure, there is insufficient pressure drop across the control valve. That's why you are not getting the sufficient flow rate. Then it is connected. But there is no direct connection between the pump suction pressure and the delta P across the control valve, which is located in the discharge line.
Okay. But the pressure available at the discharge side definitely will have some connection, delta P available at the control valve.
Yes, it is definitely, it is both connected.
But the suction side, it is not related.
No relation. In the calculation of the whatever you want to size the control valve, right? Sizing
Right.
of control valve will be related to the pump discharge pressure, not with the pump suction pressure.
Okay, sir. Okay, understood.
Similarly, suppose if I
One
say
thing,
pump control valve has nothing to do with the suction side. Suction में कोई valve होगा, manual valve होगा. So control valve has nothing to do with the pump suction side valve. But if someone closes close that valve, then obviously your control valve will malfunction. So similarly, there is no direct connection, but operational point of view, it is connected. Okay. Yes. Other questions?
one thing, what is the F factor F we are using?
It is the friction factor.
No, of course it is. There are two, na? Two method, Moody friction and fanning friction. Which have to be used?
So Moody chart is basic. See, friction factor from the F. It is fanning friction factor. It is calculated from the equation, and Moody's chart is basically graphical method. Nearly both are same. For our case, we have considered the fanning friction factor.
So both are same. One is a graphical interpretation and one is a empirical equation, right?
Correct.
There is no difference between both.
Yes. See, nearly both the values when you calculate using Moody's way or the Fanning's way, nearly there will be very insignificant difference. However, there will be some difference. जैसे कि एक में आएगा 0.015 तो दूसरे में आएगा 0.0146, right? But that difference will be very significant.
So then which can be the better way to calculate the frictional factor, sir? Via fanning or via Moody?
If you are using a manual method, if you are doing a calculation manually, then Moody's chart is better. And if you have an Excel sheet, then put a formula, fanning friction factor formula, put in the Excel sheet, then that will be better. I would recommend fanning is better one.
So,
Yes.
so how do we calculate NPSH available? Based on the pressure drop we will be getting from the pipeline which we are drawing the liquid to the pump.
NPSH available, it is basically your suction tank pressure plus pressure because of the static height of the liquid inside the suction tank minus the frictional losses in the suction minus the vapor pressure of the fluid in the suction side. So that is basically NPSH.
Sir,
can you repeat, sir?
Sir, can you repeat?
Okay, it is basically suction tank pressure plus static height of the liquid in the suction tank minus the frictional losses in the suction minus the vapor pressure of the fluid in the suction.
Sir, what is the mainly difference in plunger pump and piston pump?
Plunger pump and piston pump.
Yes.
डिफरेंस तो एक में प्लंजर है एक में पिस्टन है. Piston plunger is somewhat different from the piston, right? Otherwise both are PD pump only.
Sir, could you help me to know about what will be the effect of the vacuum in the suction vessel over the NPSH?
So if there is vacuum in the suction tank, then your NPSH available will reduce because your suction tank pressure is reducing.
Yeah.
Correct. If on one hand your suction tank pressure reduces, then your NPSH will reduce because your suction tank pressure is also increasing like suction tank pressure is also decreasing, and even at reduced pressure your vapor pressure will also increase. So overall your NPSH will reduce at vacuum.
Actually, my query is that while we are calculating the NPSH, so we are used to take the vapor pressure. Am I correct?
Correct.
Vapor pressure of the liquid that we are transferring. So we would take the vapor pressure over the vacuum. We should take the vacuum pressure, vapor pressure at the vacuum value or at the
No,
after
vapor
at
pressure
the
at the temperature. Every fluid has some vapor pressure at fixed temperature, right? So your whatever your fluid temperature is, suppose you're pumping the fluid at 30 degrees centigrade, then vapor pressure at 30 degrees centigrade.
Okay. Okay. Okay.
And that would be in absolute terms, na? Or vapor pressure calculation always does in the absolute terms, or we can do in the gauge terms also.
Any terms you do, like it should be uniform. अगर सारे प्रेशर आप सक्शन टैंक का प्रेशर है, फ्रिक्शनल लॉसेस है, उसका जो यूनिट है वही केस में आप ले सकते हो.
Okay, fine.
Absolute is preferable. Otherwise, आप उसको mostly NPSH calculations are done in meters only. So you can convert it into meter columns.
Okay. And second point, you are telling that we can take the advantage of the height of the liquid level in the tanks. So what we should consider, low level or a high level? I think in my opinion, no liquid level would be preferable, na?
In what case you are saying?
Like we have the different type of the liquid level in tanks, na? Low level, normal level, or high level. So no low level would be preferable.
See, with respect to cavitation, suppose your pump is cavitating, then go with the high liquid level. Otherwise, always go for a low liquid level because it will save the volume of the tank. अगर आपका कोई प्लांट बंद हो गया तो टैंक विल हैव सफिशिएंट अमाउंट ऑफ वॉल्यूम. अगर एनपीएसएच से रिलेट करें तो हायर लिक्विड लेवल इज प्रेफरेबल. व्हेन वी टॉक अबाउट द डिजाइनिंग, ऑलवेज कंसिडर 10% ऑफ द टैंक लेवल, क्योंकि बिकॉज व्हेन यू वांट टू एम्प्टी आउट द टैंक, in that case your pump will cavitate. So during the designing you consider the lowest possible level. So suppose whenever I am designing a pump, I am considering 10% of the liquid level inside the tank.
Okay, so in terms of low liquid level.
Yes, in terms of low level. And during operating, it is higher the level, better will be your pump operation. So operation के time पे आप 50% और 60% भी रख सकते हो.
Yeah, understood.
I have one doubt, sir. If I want to make NPSHA negative to positive, I will provide lower pump elevation, that is pump in pit. So how it affect to make positive NPSHA?
So you can increase the NPSH, boost the NPSH in multiple ways, right? You can increase the height of the suction tank. आप suction tank जो first floor पे उसको fifth पे या fourth पे या third पे ले सकते हो. Similarly, you can put the pump in the ground, right? Suppose your pump is on the ground floor and tank is also in the ground floor. So you can shift the pump underground also. That is one of the possibility, but that is difficult one. Another possibility is you can reduce the temperature of the fluid. So if you reduce the temperature of the fluid, then your vapor pressure will also reduce. Another possibility is reduce the pipeline fittings or the suction line length, so that your pressure drop will be minimum. So these are the different criteria.
And increase the size also, suction size.
Yeah, increase the pipeline size also in the suction thing.
Yes.
But sir, how it makes positive NPSHA?
ये सब करोगे तो पॉजिटिव हो जाएगा ना. सपोज यू आर पुटिंग योर सक्शन टैंक हाइट, आप फर्स्ट फ्लोर से उसको थर्ड फ्लोर पे डालोगे, सो जो हाइट के कारण आपका फ्लूइड का सक्शन प्रेशर बढ़ जाएगा ना. आपने सक्शन लाइन का साइज बढ़ा दिया तो फ्रिक्शनल लॉस कम हो जाएगा, तो सक्शन प्रेशर बढ़ जाएगा. आपने टेम्परेचर कम कर दिया तो वेपर प्रेशर आपका कम हो जाएगा, तो भी सक्शन प्रेशर बढ़ जाएगा, एनपीएसएच बढ़ जाएगा. यू कैन इंसर्ट अ नाइट्रोजन, 2 kg का नाइट्रोजन इंसर्ट कर दो टैंक के अंदर, तो टैंक का प्रेशर बढ़ जाएगा, 2 kg हो जाएगा. So then also your suction pressure will increase.
One of my doubt is that, but about the NPSH scenario in case of a positive displacement pump, or to be specific, plunger or piston pumps.
Sorry.
In our plant, we have a booster or a centrifugal pump in the suction of a piston pump, piston or reciprocating pump. So why the positive displacement pump develop very less suction, or I can say NPSH? They, is it a case?
Because the operation of a PD pump, positive displacement pump, and centrifugal pump are both different. In positive
Yeah.
displacement pump, there is no cavitation scenario, because even if it sucks the air, it will discharge the air along with the liquid. That is one of the possibility. And wherever, when we talk about the centrifugal pump, here in the eye of the impeller, the suction is created, and because of that, if your NPSH is lesser, then in that case, what will happen? Your fluid will vaporize, and those cavities or that bubbles will strike on the impeller surface, which is rotating very fast. Because of that, your impeller will get damaged. That is not the case with respect to piston. So in that case, suppose if you have a piston pump and your pump starts cavitating, right, rather than fluid, if there is a air, then what will happen? That piston pump will be acting as a compressor. It will compress the
Yeah.
air in case.
Yeah.
But in case of centrifugal pump, that is not the case. It will damage the pump.
My question is that, suppose I have a positive displacement pump, PD pump, at elevation of say 7 meter or 10 meter, but my suction sump is at 0 meter. So is it there is any need to provide me to provide a booster pump in between, or the PD pump will automatically suck the liquid and then transfer to the my downstream, transfer to the downstream?
You can also add a booster. Otherwise, I exactly don't know. But this PD pump will automatically suck. You can check the data sheet of the pump. What is the suction, right? Otherwise, most of the time, PD pump always gets the fluid. Initially, it takes some amount of time, but once it gets it, वो अपने आप ही खींच लेगा fluid को. There is no need of booster, I think.
So my I want that was my doubt. So I was want to be sure, because
Okay.
I think in the most of industry we used to provide a booster pump in the PD pump sections. So I was just want to clear that out, why we used to provide that. We can run a PD pump without the booster pump as well.
Okay, we can run booster pump. I have used many PD pump without booster also.
Okay. So there is somewhere also a case of NPSH. Then there is a case of NPSH in case of positive displacement pump. Because there will be some limit of a suction that a positive displacement pump will develop
Yes, yes,
in case. So
yes. So in
the
that
One
concept of
question.
suction pressure in a PD pump is lesser than that NPSH, then in that case you need a booster pump. Otherwise, not.
One question.
right,
What
right,
should be
right.
the design pressure of discharge line size?
See, design pressure as such will depend on the head
Because
of the.
no, my doubt is it should be what shut off pressure of pump, or it should be what design pressure of line means, by any means that should sustain the pump design pressure, right? Pump
See, shut off
shut off
pressure of
pressure.
pump multiply by 30 to 40 times of that margin. Generally, most of the time in industries, we take 200, 100% margin. So, suppose the shut off pressure is 3 kg, then line design pressure is 6 kg.
Okay.
Most of the time, it is double. For my case, I am considering, we always consider it double. So, it is
Actually,
suppose
yeah. Actually, we also consider double, but my doubt is what is the standard? Means is there any something doctor?
with respect to shut off, only we calculate. Sometimes even like series corrosive fluids, right? So in that case, you also consider 150% also. Depends on the criticality, process safety point of view,
So
how
also
critical is the
some
fluid.
people also provide PSV on discharge. So means that also to in order to save the cost. some are also, maybe there are rules, but we have to study.
Yes, so it depends on, like, we should not run on the shut off, आपका seal damage हो सकता है, तो in that particular case as a protection they give a PSP, right? But these are all very very rare case.
So actually, I have a one doubt of a kind of a case study. So in my plant, I have a recirculation line in the pump discharge of a 1 inch size, and the pump is continuously providing me 40. The over the pump plate there is a flow is given about near about 25 meter cube per hour, and the head is about 5 bar. So
Okay.
my main line is near about uh, 75 NB, 75 NB, and my recirculation line is about 25 NB. So my recirculation line continuously, after the use of for 3 or 4 months, my recirculation line continuously erode at the different corners, or I can say the elbows. The inside the wall thickness of the pipeline going to reduced after a couple of months. So could you suggest me any solution or why this is happening?
So first of all, you should know what is the reason for corrosion. So you should do a coupon test. It is not the case that only your recirculation line is corroding. Even your discharge line might also, there might be some thickness reduction, but as your recirculation line is lesser, and maybe because of lower line size, it is subjected to higher pressure. So that's why that erosion is higher because of higher velocities. Even your plant side line, your discharge line might also have some reduction in thickness. So first of all, know that reason. Now suppose if that material, whatever is corrosing the doing that corrosion, if it is going to be present, then you can increase the schedule number of the pipeline, or you can go with some coating. So you can go with corrosion proof pipeline like MSPTFE or CSPTFE.
Okay,
Main
actually,
thing
I was thinking the same.
you should study the MOC.
Yes, study the
If the
MOC,
correct MOC is
open
installed or
test,
not.
what
Sir,
type of corrosion
actually,
it is.
the construction material, the MOC is a 317L.
Okay.
And 317L, and we have just looked at the line. So there is no any traces of the corrosion inside the line, but the line only erodes. There is no corrosion inside the
So
line.
it is because of higher velocities, then erosion corrosion is
I have,
happening.
I have discussed with my team. We have concluded that there is only one possibility that the erosion due to the high velocity. So, but we have decided we can increase the line thickness, or as schedule number, we can increase the schedule number. But after all, the nozzle connected to the my vessel, will we have the same size? Will be the same size provided by the vendor itself? So
You can have
even
reduced if you have like whatever it is, you can have a okay. So thickness point of view, that you need to check. You can
Also,
have a
we
reducer in between.
also face this problem, but that problem was due to welding issue because SS pipeline are welded somehow in between. So in the welding area only there were leakages. So these are means MOC is very correct answer to your problem, I think.
yeah,
So
yes, sir.
According to
whenever
my
MOC is
is it
very
is
correct.
it the
MOC
weld
is very
joint?
correct.
Is it the weld joint which is failing? Then you should do the proper post weld heat treatment and do the proper radiography and check what type of, is there any
exactly,
fault
exactly.
in the welding.
Because these are
Actually,
the
we have a
mechanical points which we not see as a chemical engineer, but are also necessary important.
okay, but actually, we have a this kind of a problem in two plants that have a same setup. So one of the plant has a problem facing from last 3 or 4 years. So they used to do change the line. They used to they have
These
make a
are the temporary
conclusion
solution, but
that the
permanent
line
is the
size
MOC.
used to reduce. So they
So
have
there
made
is
a
only
fixer
one possibility,
one year.
then it is because of high velocity only.
So I'm thinking that if I increase the line size, so it would be somewhere make the difference or not?
Yes, it will obviously your velocity will reduce and it will definitely make a difference. You just calculate what are the velocities in the recirculation line. If the velocity is
Okay.
more than 4 or 5, then definitely that is a root cause. Velocities should be somewhere in the discharge. It should be say 2 to 3 or 3.5 maximum.
So that's why I'm thinking that earlier we are discussing that we used to have for the better BEP to extract better BEP from the pump, we used to give a recirculation line, and the size of the recirculation line in Nalvi used to be, I think, 5 to 6 times lesser than the main product outline. So this will be the case of I think mass problems generating the mass number of the plants, or I think, am I correct?
It is
No,
because
no,
of the
this is
higher
not the
velocity only.
problem. This is a solution to so that your pump should not get problem due to
Yeah.
overheating, overrunning.
I'm getting, sir. I'm getting, but I'm just discussing. I'm just putting the point. So it will be a case in मतलब normally cases में होता होगा, मतलब तो हम observe नहीं करते होंगे, but I think the line size get reduced or thickened over the period of the time after the erosion.
Yes, वो आपका high velocity ही है. If there is no corrosion material, then it is the high velocity which is basically eroding. So you can try by first of all calculate the velocity. What is the velocity? Suppose you calculate the velocity and it is coming out to be in the
More than a
range.
5 meter per second. More than a 5 meters.
It is more than 5 meter per second.
I'm just giving an idea. I think below, above the 5 meter per second, there will be possibility of erosion and vibrations. So
Yes,
I
so
think,
if it is more than 5, then definitely it is velocity only, which is basically corroding
And
the
one
line.
thing, if they are using SS317, then it is a corrosive, I think. Normally, people don't use SS without corrosive fluid.
the material is definitely corrosive, sir. It is an acid. It is a
Then,
definitely corrosive.
yeah,
But
you know the
we have
solution.
we have just installed it 1 year 1 year earlier, or we have most of the lines of the plant made from the same material. That line doesn't corrode or erode, but only that specific line get corrode.
Okay, so
Corrode.
just check. You can increase the line size and check what is happening, what is the frequency of leakage. I think that
Yeah.
will be a better solution.
Okay.
Yes.
Yeah. Thanks. Thank you.
Sir, I have a doubt, sir. So what does suction flooding mean, sir? Suction flooding, suction lift means.
Suction lift. Suction lift मतलब क्या है कि
A suction
suppose
lift pump. I mean, suction lift pump or suction flooding pump like that, sir.
that is basically nothing but आपका pump है. Suppose it is on the ground floor, right? And suction lift मतलब क्या है कि कितना डेप्थ से वो पंप आपका फ्लूइड को सक कर सकता है. Suppose if you have a centrifugal pump, right, or it is located on the ground floor. So my question is, अगर आपका पानी, if your water is 20 meters inside the ground, the surface level of the water से लेके pump का center line, if it is 20 meter, distance is 20 meter, will the pump be able to suck that fluid?
No, sir.
अगर वो 15 meters है, then if it is 15 meters, then is it possible?
Sorry, like I couldn't be able to get your question. Could you please repeat it again, sir?
So basically suction lift मतलब क्या है कि it is the depth from which a pump can easily suck the fluid. So for the water case, the maximum possible suction lift, right, it is 10 meters. अगर आपका water is at 11 meters and pump is at ground floor, you can never ever pull that liquid out because how it is related to the pressure, right? आपका कितना pressure, आप whatever pressure is atmospheric pressure is there, that atmospheric pressure will act on the pump and that all the water will flow in the pump, provided that there is no, suppose when we talk about the NPSH, What is the NPSH? That is a net positive suction head. So suppose there is no liquid level because it is underground, there is no frictional losses, so your frictional losses is zero. And suppose your water is at 0 degrees centigrade, so suppose there is no vapor pressure. So in that case, what is happening? NPSH available is 10.33 meters. That is basically the pressure of the suction tank. Your underground tank is atmospheric. There is atmospheric pressure. So if your NPSH available is 10.33 meters, and if you use all that NPSH, then in that case, if your pump is at the ground floor, then you can suck the fluid, suck the water from 10 meters depth. इसके अंदर अगर आपका fluid है, if your fluid is below that level, then you can never suck that fluid. So that's why whenever we are doing this borewell, right, we are putting a submersible pump inside. So that is nothing but the suction lift. Is it clear?
Okay. So then what about suction flooding, sir?
Suction
Flooding. Suction flooding.
Suction flooding is in order to avoid that. Suppose you want to pull the water from inside, right? You need some NPSH. So in order to give that NPSH, or initially for the priming, you have a suction pot. In the suction you have a priming pot. So you fill that pot so that it can have a proper flooded suction. That is nothing but a suction flooding. You have a priming pot in the suction line, right? That is all related to suction flooding.
Okay.
So I think if there are no more questions, then we'll stop here today. I think I have answered most of the queries, and overall it was a very good interactive session. Yes, any
Yeah.
questions? Anyone?
Hello, sir.
Yes.
sir.
Hello.
हाँ बोलिए. Yes.
Hello, sir.
Yeah, I don't have any question to ask right now, but I want to say it was a quite a comprehensive interactive session, which gives us a lot of discussions and a lot of learning about the pump. So thank you for taking this type of discussion to us, and giving a learning by discussing the things. Thank you.
Yes, thank you.
Thank you. The station of pumping temperature was very new.
Thank you,
Pumping
sir.
temperature.
Hello.
Sorry.
The point of pumping temperature you mentioned, that was very nice. Vapor pressure and pumping temperature, that was
Yes.
new and good. It was very good.
Okay.
Hello.
Thank you.
Sir, can we be share the material which you taught in this session, sir?
Is that I need to ask with the backend team how to share that. I have no issue in sharing.
Yes.
So
If possible, please share that Excel also, sir.
yes, I will
Calculation.
share. Yes.
Can you tell us any reference manual, means any book and all for pump hydraulics?
So mostly for the pumps, you should use one book is there, Understanding and Knowing the Centrifugal Pumps by Larry Batches करके है. If possible, I will also share that book. It's a very good book, right? You can also note it down if you want.
So what is the name of the author, sir?
The name of the author is just a minute.
In addition this, you can check API 610. It is
Yes,
also a good reference.
It is also good for the pump. 610 API 610 is also good.
Sir, and your name, sir?
The name of the author is Know and Understand Centrifugal Pumps by Larry Batches and Angel Custodio. You can just write down Know and Understand Centrifugal Pumps by LARRY Larry Batches, BACHUS, and Angel Custodio. It is a very good book, basically, with all the examples, all the calculations, all the troubleshooting, everything is given. It's a very old book.
Great. Thanks, sir.
Okay, sir. Thank you, sir.
Okay, so
Thank you,
thank
sir.
you everyone for joining, and I will hand over to the backend team if there are anyone. right?
Your name, sir?
Basically, we at Chem Club, we are providing we are initially, we were a educational institute providing guidance and technical sessions to the chemical engineers. Nowadays, we are growing towards the technical solution providing company, giving the solutions to the companies via simulations, via design. We are now a design company, right? So if you are interested in courses like SPEN Plus, ICES, or process design engineering or equipment designing, right? Then you can definitely course available on our website. You can contact us anytime. So only this type of live sessions will be happening in our classrooms. So it is very interactive and it is very insightful. So if interested students are there, you can definitely join us.
Yes, sir.
Definitely.
सर आपका नाम क्या है सर?
We cannot disclose the identity because we are all working professionals. We are doing this right.
Great, sir. Great.
Institute.
It was a great session. Thank you.
Yes, thank you everyone, and kindly fill the feedback form. And interested students can also get in touch with us for the different courses available, right? Okay, so thank you everyone for joining. Have a good
Thank
day.
you, sir. Thank you. Thank you.
Thank you, sir. Thank you.
Okay. Thank you, sir.
Hello.